Hello, hello. Hi.
Hey.
Hi, Amy. Good to see you. Good
And
evening. Good
you?
afternoon. How are you doing? Are you feeling rested?
Yeah, sort of. It's been a busy 17 or so hours, Jason.
Yeah,
I don't know what we've been doing.
it's been crazy, but let's just get right to it. So, thank you for joining us. There's people kind of still rolling in and joining the live stream here, but we're really excited to have you. This is the very first All Around Azure global event. This is the third of such events that have been going on just in the last 24 hours. We've had some amazing talks by a lot of great speakers, both in our Japanese time zones as well as our European time zones. And now we're here in the American time zones. And I've got Amy here, who's going to be giving us a little bit of information about what in the heck we've been doing all day and what's really in store for the rest of the show, the All Around Azure Developer's Guide to AI. So Amy, if you want, maybe you could give us just a little bit of background on what it is we've been doing, why we're here this afternoon, and what we can expect to see through the rest of the show.
Yeah, of course. So, all around Azure, the Developer's Guide to AI, it's all based on 5 different sessions that we're going to do. Each one is quite short, really. They're only 15 minutes long, but they're followed by 15 minutes of Q&A. So get your questions ready, pop them in the chat. We have people on hand to answer all of your questions, as well as passing them to Jason. So Jason has direct connection with our moderators in our chat channel so that he can then ask those questions directly to the speakers live. So please chat with us and keep engaged. It's going to be a whirlwind. As Jason says, over the last 16 hours, we've had a chance to deliver this event in Japanese over in Asia with some of our teammates, as well as then delivering it in French in the European time zone. And then finally, last but obviously not least, bringing it to the Americas time zone in English. So yeah, we're going to cover so much. So like, strap yourselves in, number one. Yeah. And then also, I just wanted to drop in there as well. All of this content directly relates to things that you can get hands-on with in Learn. So you might actually be joining us from Learn TV. Go check out some of the modules that we're going to point you to, but also certification as well. And we'll give you more details shortly.
Yeah, there's a lot of things we're going to be covering today. Like you mentioned, we've got 5 fantastic presentations to give, all from amazing presenters around the subject, of course, of artificial intelligence and the related subjects. I've been able to sit in on several of the pre-show presentations, dry runs, and they've been fantastic. I can't wait to see them all in action. And I also know I've kind of poked my head into what was happening in Japan late last night, as well as what was going on this morning. And it's been really awesome to see so many people engaged, asking great questions. And like Amy mentioned, we've got chat enabled here on Learn TV and anywhere else that you might be watching us. So we'd love to field those questions. At any point, let us know if you have any questions. The way that we're going to do this for the rest of the afternoon, the rest of the day, is we've got a number of speakers, of course. We got a keynote coming up here that we'll present for you. And then we'll move through the day, through our presentations. I believe they're around 15 minutes or so for each talk. And then we'll spend the next 15 minutes or so asking questions. We may mix that up a little bit and diverge from that a little bit. For the most part, that's kind of the format that we're going to stick with. So if you have any questions, feel free to drop those in chat and we'll get to them as we can for sure. Anything else I'm forgetting about, Amy?
No, I think that's it. I think it's enjoy yourself, chat with us. Just keep engaged, but also be inspired. This content is quick, it is fast, but each one of them is a story that we want to use to kind of inspire you to get more, like to take that time and learn more after the event. So we hope to inspire you with things like Azure Cognitive Services, Azure Cognitive Search, Conversational AI with chatbots, as well as some Azure machine learning as well to wrap it up.
Yeah, some really, really exciting stuff. And I think we're ready to go ahead and kick things off. We've got our amazing friend Seth Juarez, as well as Vinky Veeraraghavan, and they're going to get us going with our keynote here. So let's go ahead and cue that video up, and we'll be back shortly to talk to you then.
Okay, it wouldn't be a live event if 6 minutes in we have some technical difficulties. So do bear with us. We're just going to get Jason back on. Jason has like the best live streaming setup, and it's obviously the rest of us do not. And so I'm sure he'll be back very, very quickly in a moment. Whilst we are waiting, what we are going to have here is we're going to have a keynote with Seth. We are actually going to see Seth later as well. Seth's going to be one of our speakers with Venki. Venki leads our cognitive services, so super excited. Watch this keynote. It's a really, really good one. Jason, you're back. You're back.
We are back. We changed equipment here temporarily, but yeah, how about that? Just PC shut down right as we're trying to get this thing going. So let's try again. What do you say? And hopefully Seth and Vinky will kick us off correctly this time. So stand by. Hang on. Let's do this.
Hello and welcome to the first All Around Azure event series, A Developer's Guide to AI. We are privileged to have with us Venki Veeraraghavan, Group Program Manager in the Azure AI Group. How you doing, my friend? Why don't you tell us who you are and what you do?
Thank you, Seth. I'm so happy to be here. So I'm Venki Veeraraghavan. I'm the GPM for what's called Azure Cognitive Services. I have been in Azure AI for about 3 years now, and started working with CNTK for those of you from the old days. Working with Onyx and sort of the open source community with Azure Machine Learning. And then in February, I moved to become the head of product for Azure Cognitive Services. So it's been a big ride.
I mean, that's cool. You've been around the block, it turns out. When we're talking about cognitive services, because that's what you're working on now, why don't you tell us about the AI platform when it comes to cognitive services, how it's accessible to developers without prior machine learning knowledge? What say you?
Great. So the core thing with cognitive services is that we're taking some really hard problems that sort of bedeviled us for a long time, which is how do you understand speech? How do you speak? How do you understand vision? And made them into easy-to-use cognitive APIs that developers can directly embed into their product to solve a problem end-to-end. And so we have sort of 4 categories of services. One is speech, vision, language, and decision. And the idea behind that is basically these are sort of core brain functions that are just available, built by Microsoft, available to you as an API that you can just simply embed into your solution. We're also starting to do some scenario-specific services that really help understand a broader end-to-end scenario. So things like Forms Recognizer that really looks at a document, understands what's in it, and gives you and sort of cracks it open and gives you the insight from the document. Or Metrics Advisor that helps you understand how a metric of time series data, whether it's anomalous, and if it's anomalous, anomalous data point, why is it anomalous? What is causing it to be happening? So we use a lot of AI underneath the covers, but these scenario-specific products, they're really sort of just solving the problem for you, as opposed to you trying to understand how to embed all the different parts together.
So if I'm understanding you right, what you're saying is that cognitive services is broken into like core things that are AI, like standard AI problems, and then scenario focused ones. Am I getting that right?
That is right. I think what we found is that we started obviously with the core AI. A lot of it has comes from sort of our years and years of research that we've done at Microsoft Research. But as we sort of built those out, what we've seen is customers end up solving some patterns repeatedly. So they use OCR to understand what a picture looks like, and then they compose that with language to understand, what do those characters mean? What are the words? What is the sentiment in there? And so the idea is that there are some patterns that are forming all the time. So conversational AI, like building a bot, we have speech and language that you need to build a bot, but we've seen it happen so many times that we're actually now making that into a product that we can just sort of use the bot framework with our direct line speech and really pull them together to actually solve the problem end to end. And that is something that you can use directly.
So that's awesome. I love the division. It's cool that it feels like you've morphed from building like little actual AI parts, and then you're morphing them because you're seeing the patterns over and over again. Are you taking customer scenarios to heart? Are people telling you when to put these things together?
Absolutely. A lot of the work we're doing is sort of, it's often the technology tells us what kind of problems we can solve. So it's a lot of it comes from research. We're also getting it from the customer in sort of the problems that they are looking to solve. And so it is a combination. When there's new technological breakthrough, we are able to do new problems that customers and we did not think was possible. So that's kind of cool. And then the same thing, customers also asking us to solve explicitly, hey, look, increase the quality of the AI in this space. And so we invest in sort of making sure that that's great. So a good example would be translation, where lots of customers have domain-specific translation needs that they're asking us to do. And so we sort of invest in solving that.
So speaking of customers, are there customers that you can share with us what they're doing and how they're being successful with these services?
Absolutely. A couple of recent customers that we've sort of talked about, I want to sort of cover because they're just sort of new technology that's coming out and sort of shows the power of the technology. So first I want to start with RXR. It's a company, we'd actually talked about this company at Ignite last month. And what we're doing there is using our new vision product called spatial analysis that really allows you to understand how space is being used. As you can see, like, where are people in the space, where what are the other items in the space. And the company RXR is a realty company, and they've been using it inside their buildings to really look at the health issues that they're looking at today. So they want to better understand, where are people moving through the building? Are they socially distancing? Are they sort of following all the health guidelines? And it is an offline thing, so it's not like corrective action in real time, but they're using all this data to actually figure out where are the choke points, where are people getting jammed up, and so then they can reconfigure the way the users of the building are moving through the building. So that's really cool. It's our first time. Couple of cool things. It's the first time we're doing video understanding with our AI. That's step one. And two, it's also a place where we are starting with the edge first. So this is a place where we're using the AI in containers on an on-prem sort of device. And it's actually doing a lot of the video processing on-prem and then sending the insights up to the cloud to be sort of managed and sort of looked at the insights to do analytics.
Yeah, that's cool. I was going to ask about that because you're probably like videoing people, and people don't want that to leave premises, and so that stuff doesn't leave the premises in any of the RXR buildings.
No, it doesn't. It's basically what's happening is all of the video comes into the premise. The video is run, and then sort of distances and like on floor 5 in this corridor you have X number of people, or here's how many violations. That's what gets sort of captured and sent up to the cloud to be analyzed by the RXR folks.
That's impressive. So I know there's probably a ton of other customers, but we have a limited amount of time. I'd love to get your thoughts on the future of these AI services for developers.
It's a great question. It's sort of we spend a lot of time as product management thinking about where we're going to go. I think of 3 different vectors where we want to innovate and sort of get better at. One is in AI quality. I think increasingly we have seen huge improvements in AI quality with these large-scale pre-trained multimodal models. So things like the Turing work that we've announced before. We have our own internal work around multimodal with translation and language. These BERT is another example. So these models are becoming very large and they're becoming very good. And the question is, how do you make it super easy and super cheap for someone like yourselves to use them in your application? So that'll be a challenge that we're sort of working through, which is how do I, compress the model, distill the model, get the AI quality still running and available in an API that is super easy for you to use inside your application. So that's one. Two is we want to sort of increasingly look at more and more solving the problem end to end. There are emerging scenarios as the industry matures and people know how to use AI, beginning to see more and more of these patterns. So, transcription, bots, conversation agent, virtual agent. So we'll be looking at more and more, how do we sort of take these scenarios and sort of just solve them with products. So that's another one. So you'll see a lot more about that coming from us. And then finally, really making your day-to-day experience as a developer super great. So, starting with developer experience. So, we're investing heavily in SDKs in all the popular languages to make it really easy to go from instead of just using a REST API and sort of caring about keys and everything else, using a much simpler day-to-day experience inside VS Code or something like that. And then the converse of that is building a great user experience for our subject matter experts who are actually building and managing the AI. So if you want to do a conversation design, dialogue design, if you want to build a voice, sort of the experts and the talent who are going to be helping build that API, building that AI, how do we make a great experience for that? So you think about that as a third leg, which is the user experience.
These are awesome three things that y'all are working on. Now, a question that I often get and I want to pose to you is how can we promote responsible AI practice? I mean, what is Microsoft doing to promote them internally, and then how can people using these AI services do it in a responsible way?
Oh, superb question and highly timely. I think responsible AI is. I think people are increasingly figuring out that this is a super important topic because as AI sort of starts seeping into all parts of our day-to-day lives, we do have questions about what it does, what should it do. So what Microsoft has done is create these 6 principles that you can see on our website. They're fairness, reliability and safety, privacy, inclusiveness, transparency, and accountability. They're big words. They sort of mean a lot of things, but let me break it down for you in terms of what it means from a product perspective. So we think about 2 big areas: responsible development of AI. That is the work that we do in our team about how we sort of build the AI. And then the second one is responsible use, which is how do we help our customers, all of you, to use the AI in a responsible way. And so let me break it down a little bit more. So in development, it starts with how do you get the data for training? Do you get the consent of the user? Do you get informed consent? So you're really being clear on what is the sort of people know what they're giving the data for, so for training. There is things like, do you get the adequate distribution of data with all the reflected groups? Do we do fairness testing and bias testing? You've seen lots of stories around this in this space of people who have not done it. And so we are really getting a lot more structured about how we run an engineering system to really make our responsible AI lifecycle sort of really good at sort of capturing these issues. So that's one. The second one is, now that we've built this model and we know what its model is trained for and what it's trained with, we want to communicate that to you as the user, as the consumer of this AI, because that way you know what it's meant for. So we want to make sure that you're not using product review trained data models on people review, right? So we want to make sure that you understand what it is that we're giving you transparency on what we've built our model on. What our data is, and then what are the expected use cases. And then in some cases, where the AI can be quite sensitive in use, we also are increasingly asking for customers to actually tell us what scenarios they are using it for, and then approving them. So we're sort of limiting access to some of these scenarios such that we can make sure that the technology can be used in the right way, in the right place.
So just one question: when we train our models, the Microsoft models that people are using, where does that data come from?
So it's an excellent question. So we normally get our models through sort of synthetics. We often make the models, make the data. We also collect data through we actually purchase data. So actually we go and get the data, and then there's publicly available data. The one thing we don't do is actually use data from our services, from our commercial services. So so that is another place where we feel like the customer trust on giving the data to us is honored.
That's awesome. Like, and that's the thing. Like, I have seen email threads, maybe I shouldn't say, where they're like, "Hey, our service isn't very good at this language. Let's pay some people to do some translations for us." And I've seen that like this. And so the ethics of, we're not just like paying lip service to it, we're actually doing it internally as well. So just to finish up, we've got about a minute or so. Tell us, what do you want people to go and do today?
So AI is a super exciting space, and it's very easy to get into. So I recommend all of you sort of go to try them out. Whether that's speech, vision, or language services. Try them out at azure.com/AI.
Now, do people is there a free tier to this? Can people use it?
Absolutely. I should have mentioned that. Yeah, when you go to azure.com, you can sign up for a free account. That gives you limited capacity to go try all these things out. And then once you're happy with it, then you can sort of use more.
And I think it's really cool because, like I said, literally you just call the API and things happen. And as far as I know, and again, maybe you can correct me, this is one of the few clouds that lets you lift and shift down on premises. Is that right?
That's right. We are the first AI services to actually offer our AI in the form of containers. And so our customers are able to build hybrid solutions, able to deploy this AI wherever their solution needs to be run. And so we, over the last year and a half, we've been releasing containers for almost all of our services. You'll see more of that coming.
Well, thank you so much, Venki, for being with us. For those that are watching, remember, go to the AI Fundamentals certification and make sure for the rest of the event, get inspired, get learning, ask questions of all of our live speakers. Thank you so much for coming. Enjoy the rest of the event. Back to you.
Okay, awesome. Thank you, Seth and Venki, for that amazing introduction to cognitive services and some of the stuff that we're going to be talking about. Some really great stuff in there that we'll take a deeper dive as we move forward throughout the day. We've got, like we mentioned earlier on, 5 different talks that we're going to be going through, covering lots of different areas within the Developer's Guide to AI. But to kick things off, we're going to bring in now our first speaker, a good friend of mine who I've had the pleasure of knowing for a number of years. And every time we get together, we have amazing conversations, and it usually focuses around stuff like this. I'm really excited to bring him on now. So maybe we go ahead and invite our good friend, Anthony. Anthony Bartolo, how are you, my friend?
Good, man. How's it going?
Great, great. Sorry for the technical glitches this morning. I've switched to different cameras here. Hopefully we're working through all this stuff, but it's great to finally see you. Pandemic's been hard. How are you been, man? What's going on?
It's same thing. Pandemic's been hard, but what's been awesome is how the community has come together from a global perspective, and how everybody's openly and freely sharing information and doing events like these based on the passion that we have to not only share but learn from others and what's going on. I think this is, in terms of the pandemic, the learning hasn't stopped, the sharing hasn't stopped. We were fortunate to be able to travel around the world during the Microsoft Ignite tour and have that same interaction. And I love the fact that we now can continue that through events like these.
Yeah, absolutely. I miss traveling. I miss being with all of y'all and doing this work in person. But it's so nice to be able to reach out and connect with you and connect with everybody who's watching us on the live stream. It's so nice to have you all. We're watching the numbers go up and up, everybody joining. So really excited. And I know some of the stuff that we're going to be talking about today with you, Anthony, is a little bit related to, kind of keeping people's well-being in mind as we go through these tough times. You want to give us a little idea of what you're going to be talking about?
Yep. So we're going to do an introduction on computer vision for automation in challenging times. What's interesting is the amount of rapid adoption and the amount of transformation that's occurred within the last 6 to 8 months. Is in essence 2 years worth of transformation. We really had to quickly understand and really change the way that we do things in terms of how we conduct business and how we interact with others, especially because, what the pandemic entails in terms of the way that we are in contact with one another, right? Everything from individuals gaming on networks or discussing ideas and sharing items in social. for us, we have our weekly meetings and our all hands, and everything is done in such a way where we can still collaborate. But in terms of the technology piece, what's been interesting is if you're watching how technology is being adopted, similar to what computer vision in terms of its adoption, it's no longer a piece where it's, hey, here is the technology that we have. Here is AI in a nutshell. Let's take this and rub it on our product and either make more money or save money. We're well past that now. Now what we're looking at, what we're seeing is, here's the problem that we have. We have a situation where we all need to be at home and we still need to work. We still need to provide for our families. How does technology further enable us of that? Jason, back in the day when you heard about AI, what was the biggest concern that people had in terms of the adoption of AI?
Well, it seems like a big part of it sounds super complicated. It sounds like the future. It's the things we see in sci-fi movies and stories about, AI gone wrong and all that kind of stuff. And it makes you think that it's so complicated that you can't understand it, or that it's smarter than you and it can, do all these things. And so it puts this veneer on the topic of machine learning, artificial intelligence, all of that it's really, really super, super difficult to understand and wrap your mind around. The things I'm learning in my time, kind of, diving headfirst into a lot of this, is it's really just about data. It's just, you're just kind of slicing up, dicing up, using data in a lot of different powerful ways. And it's just data, So I think that's kind of helped me rewire my brain when we're talking about this kind of stuff, is that it's not as complicated as it needs to be in my mind. And the really nice thing is that there's so many great tools out there. And most of the stuff we're going to be talking today is actually going to demonstrate this. There's so many great tools out there that make it super easy for you to not really have to understand that complicated stuff. It adds that layer of abstraction so that you can now come in and do some really simple tasks. And yet behind the scenes, there's some really amazing magic that's happening.
So what's interesting is that, complexity was the number one challenge in terms of how do I, adopt this technology? How do I manage this technology? How do I ensure that I'm keeping to my ISO standards or certifications that are required based on the industry I'm in? The other challenge that a lot of people were facing that have expressed this to myself directly has been, if I adopt artificial intelligence, or if artificial intelligence is adopted within my organization, will I lose my job? Will I be replaced, right? That's another big concern that people have. With the pandemic, what's been interesting is the inclusion of AI services in regards to the way that we do activities, or what we did activities previously, has now been seen as, this is an awesome thing, because I can't be within contact of an individual or of an object that I'm usually doing my day-to-day services with. And so with the automation that's provided through artificial intelligence, cognitive services, custom vision, machine learning, you name it, it's a whole different world in terms of the way that we perceive what artificial intelligence can do for us. It's no longer the replacement or cost savings measure. It is the ability to move forward in terms of what we're trying to do in our daily lives to ensure that the economy keeps going, that people are kept safe. The whole aspect of artificial intelligence is that new capability that ensures in this time of the pandemic that we're in right now, we can still move forward with our lives.
That's right. Yeah. It's been pretty impressive. And to just your point and to what they were talking about in the keynote, it's so great to see these things come to life and actually start benefiting us. Things are really tough right now, but it's amazing to hear about all the new projects that have emerged out of this. Like you mentioned, like we've kind of jumped ahead 2 years worth of technology and thinking, it seems like. So yeah, it's really fun stuff.
So here's an example of one of the projects that I was on. And originally, when the people at Indro, which is a startup based out of Vancouver, BC, came to us, they had this situation where, on behalf of the Canadian Coast Guard, they were operating drones. These are gas-powered drones that you would fly out to sea and survey when a ship is under distress. So a ship is calling an SOS. And the ship's under distress, and initially the Coast Guard would send a ship out to adhere to the situation. Sometimes it was life-threatening, other times it was not. Being stranded out at sea is never a good thing, so it's always life-threatening. But in terms of the services that are required for that to facilitate the rescue, different ships have different equipment, and so they want to be more proactive in terms of, when we're rescuing people, what does that mean? What does entail? What is required in regards to that? In regards to this solution here, when Indro came to us initially, they were challenged in regards to having this drone fly out at sea, film or survey the area of the where the distress signal is actually coming from, capture that information, and then fly back to a central office on mainland to have the video analyzed. Now, these drones can fly 3 hours out at sea. These are gas-powered drones, as mentioned earlier. And the challenge was there's that time gap of this drone going out, understanding the situation, and then flying back, and then having the tape or the recording reviewed. So they had come to us initially because in terms of regulations, there are specific regulations in terms of the height that the drone has to fly at and the resolution that the drone has to capture imagery at in order to be sanctioned for the ability to save lives. And this is something where it's a challenge because the bandwidth that was required for these drones to capture this information and live stream this information was, was too high to be supported over the connections that they had. Remember, you're out at sea. Cellular connectivity may or may not work. Satellite connectivity most often would work, but the expense was so astronomical. It was more economical for the ship to go out at that point, so it didn't make sense. And so initially, when they came to us with this opportunity, it was, hey, can you help us figure out a way to compress the video without degrading the resolution that's required by law in terms of to save these individuals that are coming out with an SOS distress? And we actually came up with a better idea and said, well, instead of doing that, what if we were able to provide self-intelligence to the drone? And so we boiled down in terms of when doing a rescue, what is the biggest item or what is the most repeatable item that we can start with in regards to identifying when there's a problem with a ship that's in distress. Human life is important. And we boiled it down to, if the ship is calling out an SOS and is in distress and individuals are in the water, that's the number one thing that has to be reported on, because hypothermia could set in if it's at colder temperatures inside of the water. And so in this scenario here, what we taught the drones to do is over 5,000 hours of training, identifying life jackets inside of the water at different altitudes, specifically based on the regulations that require the drone to fly at, in regards to the different shades of orange of the life jackets, in regards to different weather, snow, rain, cloudy day, sunny day, the whole bit, even the water itself, if it's a choppy day, if it's a flat day, all that information being captured and being used in custom vision as a trigger. So this whole availability of, understanding, oh, I see a life jacket, and then confirming that an individual is actually in the life jacket using, heat scanning and the ability to pinpoint, yep, there's an individual in there, and then to do a rudimentary calculation based on the body mass that's detected by that heat capture, to then say this individual that's in the water, and then understanding the environmentals around the drone itself, the estimated time for hypothermia that's set in is X amount of hours, X amount of minutes, whatever they may be. And so, this was my first big foray into artificial intelligence in regards to this opportunity. But I love telling the story because it addresses a problem in terms of how do we get the proper resources out to these individuals that need rescue, as opposed to just simply adding AI. Making these drones self-aware and intelligent makes it so that you can have this ability to understand the data at the point of entry, at the point it's being captured, as opposed to waiting back for the information to be relayed back to you, which could take up to 3 hours at a time, and then review said information to make a judgment call.
That's pretty fascinating. I had no idea that you could actually, first of all, that there was even gas-powered drones that could go out that far and fly that long, but that you can do that kind of scanning and then send that information, relay that information back to make some decisions is pretty fascinating.
Well, and this is the thing, right? So Indro at the time, they didn't know. And that's one of the big challenges, right? A lot of people don't know in regards to the technologies that are available and the services that are available. You figure AI is just this replacement of thought. And, they don't know what services are actually, and sitting down with companies like Indro and really fleshing out what are they trying to accomplish? What is the idea behind the request that's coming in terms of what they want to adopt and why they want to adopt it, right? Sometimes we're too quick to say, hey, there's this technology is bolted on and let's go. And then at the end of it, you're troubled in the fact that, oh, I didn't really understand what this technology could do. It's not going to fit our needs. And now in terms of your proof of concept, you've spent 3 months doing this, and you're now out that time to really implement a great solution. So having that ability to really understand what's going on and have that ability to learn Proof of concepts, hugely important. If you're dabbling in our artificial intelligence and you're looking for projects, may I suggest, looking at nonprofits. I've been blessed to have the opportunity to work with a handful of nonprofits thus far in terms of the testing of technology and enabling them to solve problems or opportunities with technology like artificial intelligence, machine learning, what have you. And it's a great learning experience in terms of the capabilities and growing that solution and continuously evolving that solution to a point where others can replicate, others can take advantage of it as well. So case in point, we unfortunately, can't replicate the drone scenario because we're all at home and my ceiling in my basement won't allow me to fly a drone that high. But what we've done, and with the help of the community, is take this scenario, take this architecture, and create a solution that can, help with the same architecture, in essence, that we've done with the drone, help out in other situations specific to this pandemic. So the example that we're going to showcase here is, this is Tailwind Traders. They are, a retailer. One of their arms in retail is hardware, and they have, huge hardware offerings around North America. And, the challenges they have is, if you know of any hardware retailer, that the amount of tools and accessories and what have you, there's a lot. If you're a mechanic, if you're a home builder, if you're, even just a general contractor, of all the tools that you require. And these hardware stores carry all this inventory, and every 6 months, there's a count required. There's an inventory count that's required in respect to, can we reconcile what we have in physical inventory to what it says in the system, right? I've worked at a hardware store, Canadian Tire, in my youth. And I remember every 6 months, it was the same. It was, you had to go through, the store would shut down. It would be after hours situation. And you would actually be counting, this is how many nails we have. This is how many hammers we have, and on and so on and so forth. And the challenge now is, in the terms of the pandemic, there's a restriction in terms of how many people can actually be within a building or in a room together when doing work or shopping or what have you. So if you have less people, the count still has to happen. You still have to do the reconcile between what you have in physical inventory to what it says in your systems in terms of what you had. So in that scenario there, can you the opportunity to extend the inventory count is a challenge, because the next day people are going to shop again, and that inventory level is going to fluctuate, and you can't limit, you can't buy these because we haven't counted these yet. You can't do that in terms of the customer. Customer wants what they want, and they're going to buy it and take it. So that also poses as a challenge. So this is where an opportunity or a problem exists, and how we then look at what can we do in terms of artificial intelligence to address this opportunity, right? So what I first want to call out, I'm not a developer. I am, traditional IT pro, if you want to call it, but I do architect solutions, and I do call myself a hobbyist Python coder. I've done a lot of IoT Python coding up to this point. Nothing professional, but everything, in terms of proof of concepts, I've been able to dabble in. Previous to, in terms of the computer vision model that we're going to show you, I've done everything manually in terms of capturing the information that I require to teach computer vision what needs to be accomplished. And and I love collaborating with others and building off the strength of others. And Cassie has this great post which changed my mindset in regards to how do I acquire all the information that is required to teach the computer vision model what it's looking at. And so in this respect here, this is taking this model. I've dabbled in it with it via Python, and extrapolating information required. So imagery I require to teach computer vision on aspects of, and I'm going to show you that in the demo in just a second, the ability to capture that information from Bing image services of what I need to train the model with. So I love sharing this because it's a great article that details how to do this, so that you don't have to do it manually like I did. I went through Bing image search and pull out all the items that I needed to teach the computer vision model with. In this scenario here, you type in what items you want. It'll actually create you a repository of those images, and then have the ability to import that into your custom vision model for the understanding of what the optical peripheral on your device is looking at. So do check this out, because it's really a great time saver in terms of acquisition of all that data. So as I mentioned, we're going to jump into a quick demo. And again, this is based on the learnings that we've done with the drone AI model. And we've now carved it down to something where it still has the architectural look and feel of what we did with the drone, but we're not going to be tracking individuals in the water. In this scenario here, we're actually going to be tracking the tools and recognizing tools within a hardware shop for the ability for inventory counting. In the light of that, we have less individuals inside of a shared space to do the counts itself. So, Jason, have you dabbled with the custom vision model thus far?
I have actually. I got to use a little bit of it last year for when we were preparing for the Ignite the Tour. I delivered a couple of talks in the AI track, and yeah, that was my first exposure to it. And actually, I should say what I'm about to say is exactly one of the comments we had in chat here. Brandon Toes said, what really appeals to me with Microsoft is that you're making AI accessible to the layman like myself. I never thought I'd be able to get involved with AI without getting a master's or bachelor's. At this point, can a person make a career specifically out of Azure AI services? My answer to that is yes, in my very limited exposure to it, because I was able to build some really, not just proof of concept, like some really interesting things. And you're right, custom vision AI, I think to me was that front door, like introduction to, oh, you can do that. Wow, I can think of all kinds of ideas now.
And that's just it, right? You're incorporating this service based on the problem that you want to address. As mentioned, I'm not a developer either, right? So I'm, like at best an architect of solutions. But knowing in terms of what the services are that are available and understanding how that fits into play, from an IT perspective, we hear it all the time. How do we participate in regards to the development of solutions? Understanding what's available in terms of services and understanding what problems that the organization that you support need to be addressed and incorporating those services, you can definitely create a career on the creation and further enablement and evolution of this solution outside of the developer realm in harnessing tools like these. Our data scientists needed 100% because the evolution of the way that information is digested and comprehended by the services definitely requires that type of strength to evolve and continue on. But also the ideas in terms of what can be accomplished, what opportunities need to be addressed. Using tools like this, like the workbench here as a non-developer was such a great way for me as an entry point to really capitalize on the ability of, hey, this is really cool, I can accomplish this. And then me wanting to further my learning in terms of now, how do I adopt this now that I have this learn set? And I'm going to show you how I went through it. And this is similar to the model that we did with the drones, but obviously more concentrated on the tailwind traders for the hardware specifically itself. So in regards to this, we're going to go through and we're going to add images. And remember what I said, initially I added these images manually, right? Casey's blog post is so timely in regards to now having the ability to extrapolate this directly from the search engine, specifically Bing image search engine. Jason, what do you see in front of you here?
I see a lot of things that could be hammers.
Could be hammers.
Could be hammers.
Some mallets, right?
I see, yeah, a few things that are definitely heavy enough to hit a nail with, whether they're actually a hammer or not.
Now, how do you know this? How do you know that that's a hammer?
Yeah, it's a good question. I've seen hammers before. I've used hammers before. I've held them in my hand. I kind of just know what they look like and how they're intended to be used.
When I was a kid, I had the toy kit that had this was a hammer, this is a screwdriver, this is a wrench. Like you're taught from a very early age in terms of recognizing what the object looks like, right?
Exactly.
So in terms of this computer vision model, what we're doing here is we're taking these images. These are the images that we have as a hammer, and we're labeling it, as you can see, as a hammer, right? So yes, there are some mallets in here, and some people have brought that up in the past, but that's great. So that in this scenario here, you can show that there are a couple false positives that need to be addressed, and I can actually remove those images from this data set. But remember, we're trying to do an inventory count here, so I'm going to go through and I'm going to start adding other tools, and now we're adding a wrench into this, and we're going to go through and add all the tools. We're not going to sit here and do all the tools, but as you can see, I can add all the multiple tools. I can have multiple labels, one per image in terms of what the tools that we're looking at. And you can see here in terms of the tags, I've got 68 hammers and 51 wrenches. And what I didn't do is I go and train the model. And so when I'm training the model, and what that means is now the computer vision workbench is going through and understanding from the imagery that's provided to it and the labels that are attached to the imagery, what it's actually looking at, in the hopes that when it has the ability via a peripheral that can see to look at objects, to understand what it's actually looking at. So once the iteration has gone through and it's done the learning and what have you, it comes back with a precision and recall rate in terms of of what I was taught of what the differences between a hammer and a wrench are, the understanding from the computer vision model of what was seen in terms of the data set that was provided, right? So understanding that a hammer has the blunt end at the top and the handle at the bottom, understanding that the wrench has usually a shape that allows for a nut to fit into to twist tight or to loosen, right? Those differences and the labels that are attached to that made available in regards to the understanding of what objects are being seen via this model. Once that's been completed, you're now taking this ability to export that data for the availability of understanding this capability from the entry level. So in doing this, you do actually have the ability to take this model and input it into device of choice, depending on technology that's required of you to adopt to, for an entry point understanding of what the object is that the machine or device is looking at, which is pretty cool. I love the fact that there's an iOS model made available, or the Docker file made available that you can run this on a IoT device at the entry point of the data capture. Jason, in terms of IoT adoption, how much data do you think is being captured right now, and where is it actually being stored?
Okay, so what's being captured? Well, there's not. As far as what's being stored, I can't specifically answer that. I don't know what's being stored exactly. What's being done here is it's going through the images, and I believe kind of parsing through almost pixel by pixel to figure out what's what. And that turns it into numbers, zeros and ones, and sorts it all out. That's sort of my vague understanding.
Yeah, no, and you're 100% correct, right? So what's being stored is the shapes and the pixels and understanding in terms of what the objects look like. But from a data perspective, could you imagine, Jason, if all these peripherals were capturing all this data at the endpoint and sending all that raw data to the cloud for processing?
It's a lot.
It's a lot, right? And the amount of time that would take. Can you imagine that, an individual sitting there with this device and capturing images of hammers for the count and waiting for the device that they're using to understand that the hammer is a hammer, and waiting, let's say, 20 minutes for this device to recognize that it's a hammer? Would that be proficient? Would help the solution? It would hinder, right? Because nobody has time to wait for 20 minutes for an object to be recognized, right? 80% of the world's data is actually being captured within the last 2 years, which is insane. It's the amount of data that's coming in is tremendous. The whole aspect of edge computing is the availability of making devices on the edge smarter to understand the data that they're receiving, so that they can do rudimentary calculations and understand, hey, I'm looking at a hammer. I can identify that I'm looking at a hammer. I don't have to send that imagery back or that notification back to the services that I see a hammer. I have to send back that I've counted 15 hammers. That's it. Greatly reducing the amount of data that needs to be captured and only capturing the information that's important in terms of the purpose of what you're trying to accomplish.
Got it.
So in this scenario here, what we're actually going to do is we're going to export this as an Onyx file. And the reason why is the Onyx file is an open source capability model of understanding what they're looking at, the result of what's been trained in terms of the computer vision model, and what the object or peripheral is looking at to understand and to provide response after that trigger of understanding, yep, this is a hammer. Let's do a count now as to how many hammers I see. And we're going to take this model and we're going to export it into Unity. And the reason why we're going to export it into Unity is we're going to take this model, again, is the open source understanding between the hammer and a wrench. And of course, you can do multiple objects, not just hammer and wrench. I'm going to show you the demo of that in a second. But we're going to export it into a HoloLens. Now, this is extreme, of course. This is to show the high end in terms of what can be accomplished in terms of porting this model to HoloLens. And thank you very much to the community for helping out with this. And the code, if you want to look at it, it's been forked into my repo, aka.ms/wireless life, but the original code is accessible as well. I had to make some slight modifications for utilization on the HoloLens, but the ability to go forth and replicate what we've done with the drone AI on a HoloLens and not require connectivity of the HoloLens. So the HoloLens itself can recognize the objects without the connectivity required based on the camera that it has based in it. And again, this is an extreme example. You can take an NVIDIA device as an example, a Jetson Nano device, and connect the camera to it and use the same model to do object detection as a trigger and to initialize I want to see and do a count on hammers. I recognize the hammer and then do the count and capture only information on the quantity of hammers, not the fact that you've seen an actual hammer. So as the example that I'll share, this looking via the HoloLens right now can detect a basketball, and it shows you the precision in terms of understanding what it's looking at. And then looking at a soccer ball, or for European friends, football, the ability to recognize the objects without connectivity at the entry point. Then, the next trigger, like it was with the life jackets, was now do the capture of the environmentals and understand type until hypothermia catches in. In this scenario here, count how many wrenches and hammers for inventory. And of course, more than just wrenches and hammers, but the ability to use that as a trigger and an identifying point to really understand around the world what's being seen via these peripherals from the entry point or the edge, and without needing to capture all the information or have constant connectivity. Now, if you want to explore computer vision further, I am a tactile learner. I like to do things hands-on. I like to break a lot of things. A lot of things behind me are broken based on experience I've done, the experiments I've done thus far. Do check out aka.ms/AI/ML10. This provides you the availability to go forth and practice what was shared today in terms of this presentation, and really start exploring what the services actually enable. And don't limit yourself and say, I'm not a developer, or I don't code in C#. Go out there and dabble and understand. What I love about Microsoft Learn is the ability for the inclusion of everyone to learn at the pace that you want to learn at. And the modules that are made available in this Microsoft Learn collection is such that hands-on theory, going through best practices, taking that information that you've learned and moving forward with that. Also, certification, right? This is another thing, some organizations require it, some organizations don't. I use certification to be not a proof, but yes, I've learned everything, in regards to this. I've learned, it's a confirmation of I'm understanding the services that are available to me, and having that confirmation means that, I can confidently go forward and say, I see this problem that we can address using these services. And then you're always learning, just because you're certified, that doesn't mean that you are the know-it-all. I always, abide by being a learn-it-all and continuously learning and make capable of my learnings and sharings with everybody else around the world to be in an advantage of adoption of services. But the availability in regards to this capability of certification means that, hey, from a foundational level, I understand what's going on. I can, then grow from there. So that was it for the presentation piece. And, what's awesome, like I said, is and what was commented online was this is not limiting to if you're just a developer. The availability of having the comfort of learning from any asset, from any aptitude, is there for you. It's just up to you in terms of your ambition to do so and your creativity in terms of designing the solutions.
Yeah, absolutely. And this has been great. Anthony, thank you so much for sharing all this amazing information and some of the stuff that we can do with custom vision, AI in general. There's been a few questions. I'll ask you just one here briefly before we move on to the next one, and then we can kind of follow up with questions in chat. But we've got a great question from one of our people chatting with us over at Learn TV. Feel free to drop into the chat over there and ask more questions. The question was, if you're getting started in AI, what's a good programming language that you would recommend to be familiar with a lot of this stuff in the AI world?
So for me, it was Python, only because the entry level was so low. I actually tried to do some adoption in PowerShell as well, but I found that Python was a lot easier in terms of the entry point, specifically around IoT. That's in essence, what I started out with in terms of the exploration around machine learning. I was presented with a problem. Actually, the problem that I was presented with was how to build a better mousetrap. And it required me to do coding on Python for the adoption of understanding when the times a mouse was caught. The big thing here is in regards to your comfort level. What coding language have you started in thus far? Have you done JavaScript? Are you doing Node.js? Are you doing C#? It's pretty much based on what your comfort level is and what platform you have to develop on. For me, because it was IoT, Python was the best entryway for myself.
Great. Yeah, I think I've heard the same for many, especially if you're familiar with Python already, like a lot of the stuff I've been playing with is already Python code. It's, we're using notebooks that is very familiar with Python, or if you're familiar with Python, all that whole world feels very comfortable for you. So, well, this has been great, Anthony. Appreciate you taking the time to share all this wealth of information with our audience. We've had some really great questions. I know that there will be more. Feel free to drop those into chat over at Learn TV, and Anthony will be hanging out to address those questions as well as the rest of us. So with that, thank you so much, Anthony, and we'll move on to our next guest here. And the next person we have joining us, hello, Amanda. How are you doing?
Hey, Jason. Doing well. How are you?
I'm pretty good. We've got through a few technical issues this morning. I'm still using the wrong camera. You can see the underside of my basement floor here. But otherwise, things are actually going well. We just had a really awesome conversation with Anthony. I don't know if you saw that, learning about custom vision. So give us just a maybe two sentence idea of what we're going to learn from your presentation, and then we'll move forward.
Yeah, so today we're going to be talking about how you can extract business value from conversation data, from text and audio data. And so we're going to use it to drive business models forward.
Awesome. Well, I'm going to get out of the way on this one and let you have the stage and take control. We will address all the questions at the very end. So if you've got questions, drop those into Learn TV, into the chat, and we'll throw those up and chat with you at the very end. So I'll let you have it.
All right. Thanks, Jason.
Bye.
Yeah. All right. Hi, everyone. Welcome to our second session, Extracting Value from Text and Audio Used to Inform Business Strategy. I'm Amanda Wong, and I am a cloud architect at Microsoft. Today, we're going to go over how you can use Azure to add speech and language capabilities to your business applications. Our use case is an online retailer's customer service center. But the concepts and tools you'll learn here today will apply to many other scenarios as well. Let's get started. The customer support center that we are going to improve belongs to Tailwind Traders, an online retailer for home improvement tools and services. Like online organizations across industries right now, Tailwind Traders relies on call centers and support agents to deliver excellent customer service. However, with everyone at home during the pandemic, the demand for home improvement tools has skyrocketed. It makes sense. Consumers are spending less money on entertainment and travel, and more money on those long lists of projects that they've been meaning to get to. In fact, the latest US Census Bureau report came out with a statistic that almost 25% of sales have gone up since the start of the pandemic at home improvement stores. So what does this mean for Tailwind Traders? It's great for business. But with this increase in sales, we're also seeing a new demand for support among customers. But Tailwind Traders has something its competitors don't. It's completely online. So this is a great opportunity to grow since more folks are shopping online these days than going into stores. So we want to take advantage of this opportunity of being completely online by standing out with excellent customer service and using customer insights to scale more quickly than competitors during the pandemic. Enter Azure Cognitive Services. Our goal is to make Tailwind Traders Support Center a truly modern, intelligent call center. With AI, we're going to improve Tailwind Traders Customer Center to automate processes and help them learn from every single support ticket. That's right, every one of the thousands and thousands of support tickets that we see every day. By adding speech and language capabilities, we can ultimately help Tailwind Traders reduce costs, identify areas for improvement, and overall increase customer satisfaction. To do this, we'll be walking you through how to use Azure to store massive amounts of text and audio data. We'll also show you how to analyze that data using cognitive services. And finally, we'll create automated workflows using logic apps and extract valuable insights using Power BI. Let's learn a little bit more about what we're dealing with here. Tailwind Trader support tickets come in mainly two forms, emails and phone call recordings. They want to learn from both of these at the same time. But this is kind of tricky, dealing with two different types of data. On the one hand, you've got unstructured data, which you can think of as the most common data types around us. Photos, PDFs, phone call recordings. In fact, we have a great session right after this about unstructured data, so make sure you stick around and stay tuned for that as well. But in contrast contrast to unstructured data, we have structured data, which is a lot more database friendly and easily machine readable. Emails from customers are a great example of structured data because they come in consistent formats. Instead of having separate storage options, we're going to simplify the process a little bit and turn to Azure Blob Storage because it's great for both types. Azure Blob Storage also scales really well. With the holidays coming up, we might see an uptick in requests for help with orders for Tailwind traders. Not a problem at all because Azure Blob Storage can provision resources and storage space as needed. In fact, using Azure Blob Storage is unbelievably easy. Let's take a look. Here we are in Azure Blob Storage, Storage Explorer, which is a free desktop tool, and we're going to navigate to our blob container for Tailwind traders. And we're going to just upload some new data that we have seen from customers in the form of emails or phone call recordings. And once we upload that, we're going to make sure that it looks right. And while that loads, of course, you can use the API or SDK for Azure Storage Explorer to access your blob. But here is our data right here. And it's a great way to visualize and retrieve your data using Azure Storage Explorer. So now that we know where we're putting our data, the next step is to analyze it using the Text Analytics API to extract new insights. With Azure's Text Analytics API, we can take in call transcripts and emails and analyze them for sentiment, extract key phrases, and identify proper nouns. Sentiment analysis is actually a really amazing tool because it provides a score on each customer's input and whether their statements reflect a negative, neutral, or positive outlook on the company. Today, we're going to use it to learn where customers are having the most negative sentiment or pain points, as well as the highest positive sentiment, to see where we can improve the areas of business. After that, we're going to turn to key phrase extraction, which is going to help us get a high-level overview of what each support ticket is really about. Key entity extraction takes that one step further by giving us specific product names or even the names of our peer companies as valuable information in improving the business model. There's a lot more that this Text Analytics API can do. These three methods that you see here are just some of the several that it offers, as well as many of the other Azure Cognitive Services that we have. So we highly encourage you to check those out to see what it can do for your business applications. Let's see the Text Analytics API in action. So first, our original data is in the form of a CSV table, and this is all the metadata of our phone call transcripts and emails, such as date created, whether it's been escalated, the region that it came from. And on the far right, we can see the raw text input that we want to analyze. So we wrote a simple Python script using the Text Analytics API. And when we run that on the code, we will get an output CSV table that looks pretty much the same as our input table. But on the far right, you can see two new columns, key phrases and sentiment. And this is giving us the key phrases for every single customer support ticket, as well as the sentiment. And that's awesome. We're going to show you how we can use this data in a moment. We said earlier that we wanted to make this customer service center intelligent. Well, now we're going to build a machine learning model to predict what a customer's concern is about for every new support ticket that we see. Azure's Language Understanding Service, or LUIS for short, is a low-code route to training and testing a natural language understanding model to support the call center. With LUIS, we will classify each language input by analyzing what's being said and categorizing it as one of several business area concerns, such as design recommendations, pricing questions, security help. For example, if someone's asking us about an update on when their delivery might arrive, we can troubleshoot that by sending it to a specialized team that is trained to deal with those logistics questions to close out that case much more quickly. Being able to filter calls and direct customers to get the right kind of help based on their problem can increase customer service efficacy and efficiency. So here are a few concepts, as you can see on the slide, that are key in training and testing a model in LUIS. With entities, we get some metadata, some high-level overview of the support ticket. It's a good snapshot of what's going on. This is very similar to what we just saw in the Text Analytics API key phrases method. And with intents, we can understand the underlying goal or action of the user in every language input that they give us. Training a custom model can be done visually through Lewis's UI-based interface at lewis.ai. Of course, you can use an API or SDK, but here we're showing you the interface of all of the intents or business categories that we're interested in searching for in every new support ticket that we get. So let's look at one of the business categories or intents. And here is one of the examples that we are using to train the model. The hammer I purchased is supposed to be ergonomic. Everything's supposed to be ergonomic now that we're all at home. Our tables, our chairs, even our hammers. So this is an example that we labeled through www.lewis.ai. You can upload a training data set yourself to this interface or through a Python script. But here we found it a lot easier to label training examples. And here's another one about asking about available brands for kitchen tables. We're going to train and publish this model. And so now that we've done that, we can test it with a new utterance, pretending we're a customer, I don't know, asking about who to call if we want to get a bathtub installed. And so Lewis is going to think based off of the trained data and say that's about services with a 0.873 confidence score. So that is your introduction to training a natural language understanding model to classify input text from customers. We didn't have to write much code at all. It was through this interface, so it made it a lot easier and faster. Now let's transition to how we can complete the full modernization of the call center. Simply categorizing customer concerns doesn't help that more support requests are slamming the support center every day. And with more traffic coming to the website, we certainly don't want to hurt potential sales by giving customers a bad experience. We're going to use two apps to accomplish this, Logic Apps and Power BI. And together, they'll optimize Tailwind Traders' response to existing and future support tickets. Let's start with Logic Apps. Logic Apps is a no-code way to automate workflows by combining apps that are critical to your business. For us, those apps are going to be Outlook and Lewis. We'll set up a system so that customers can receive an automatic email with relevant information to their inquiry. And while they sit tight on the back end, the support ticket is going to be forwarded to the proper logistics team to close out that case much more quickly. And once we automate those workflows, we're going to turn to Power BI for help on visualizing our data from a high level using our business intelligence tool, Power BI. A Power BI dashboard can make it easier to understand how to resolve common issues and reduce future support call volumes. So what's the takeaway here? The takeaway is that it's easy to share high-level insights with a leadership or product team, since you can customize visualizations and dig deep into potential opportunities for improvement. You can see here in the Logic Apps Designer interface that we set up a connection to the Tailwind Traders email so that we check for any new emails that we get from customers. We parse that object and pass it to Lewis to get that intent, that prediction that we just saw. We unwrap that and use it to send an email back to the customer. You can also use Adobe, GitHub, and Outlook, and many other apps that are relevant to your business workflows. So let's see this in action. Let's run it. Let's pretend we're a customer contacting Tailwind Traders. We want to make sure that this works. We're contacting them about our kitchen sink not being delivered yet. With delivery services backed up, we would like an update. So we'll send this off, and back in Logic Apps Designer, we can see that all green is a go. It processed that email correctly. And on our end as the customer, we can see that Tailwind Traders has told us to sit tight. We can see you're contacting us about delivery speed, which is correct. And in the meantime, our email is being handled by the appropriate team. Again, you can do so much more with Logic Apps to make repetitive business needs more efficient by automating them with your own custom app. And remember, when I said that we'll learn from every customer support ticket, think about it. The thousands and thousands of support tickets are going to come in play right here. And this demo shows a custom Power BI dashboard that we created using custom Python scripts. You can see here we can select by region, we can filter by negative, neutral, or positive sentiment, as well as see the key phrases. But if you don't want to use a custom Python script, you can use one of our built-in visualizations, such as a word cloud, as you can see in the top left, top middle. And you can select different words, and the visualizations will refresh accordingly. But if you prefer to view this data quantitatively, on the far right side, you can see that we selected the top 3 business categories or intents where customers had the highest negative sentiment. And these 3 issues, services, price, and delivery speed, these are the areas of concern where customers had the most pain points. So we definitely want to dig deep into here and see what we can do better and how to help Tailwind traders. When it comes to service issues, we can see that the most frequently used words have been refunds and orders. When it comes to price issues, we can see that customers are asking a lot about discounts. So maybe this is a good time for Tailwind traders to use this information to set up some deals for customers and get more sales into the business. So we could take it even one step further and analyze the correlation between specific product names and sentiment. There are so many opportunities here to learn from the data. High-level visualizations of what's going on helps us make sense of the thousands and thousands of business tickets to understand the health of Tailwind traders. This way, Tailwind traders doesn't have to drill down into the specifics. They can give a high-level overview to decision makers to drive the company forward in a volatile environment and grow in areas that are in demand. So with that, we hope you learned a lot about speech and language offerings in Azure. Modernizing a call center is just one of the many ways that speech and language AI capabilities can be applied to solve business challenges. The processes we learned today can be applied to many other scenarios where conversation is involved. Think of medical consultations, sales calls, business meetings. The AI tools that we share today can help. So if you want to learn more about how cognitive services can help solve your business challenges, get hands-on at MS Learn at aka.ms/AIML20. And again, we're going to prop open the certification prompt. So learning this material is a big step towards becoming Microsoft certified. Check out aka.ms/AI900. And I will be joined by my teammate Devanshi to talk with Jason about any questions and to talk more about the issues that we discussed today.
Awesome. That was amazing, Amanda. Thank you so much for that demonstration. And hello, Devanshi. How are you?
Hi, I'm good. How's everyone? That was a great session. We've had some great ones in the past as well. I've been tuning in.
Yeah. In fact, so many of the subjects that you were going through there are near and dear to me. First of all, the logic apps is something I feel like I'm doing a logic app like once a week that solve some problem I have. So to see those in action here is pretty fun. And then I love that you brought up Lewis, the language understanding aspect. We didn't get to talk too much about that with Anthony in his demo, but the idea that we can now look at text and understand what people mean, or at least develop a probability around what they mean, is I think what opens up demos like you showed. Open up the brain to like realize there's so many things we could be doing if we just took the time to understand what people are really asking for. I know personally, I've had a lot of support tickets with different service providers just this past year that we go round and round and round. And I feel like this demo that you showed off today would have solved so much of my headache and problems, and we could have got right to the solution. So very interesting presentation. We've got definitely some good questions in chat. So if you got more questions, drop those in there. We're going to get through them as quickly as we can here before we move on to the next one. So one comment that we had, or statement we had in chat over on Learn TV from Brandon Toes, was that Logic Apps service seems like a more broad version of Power Automate. Is that an accurate description? So
yes.
Yeah. Okay. Go ahead.
So Logic Apps is basically the bigger brother. So Power Automate is built off of Logic Apps. And that's how it works. Yeah. So that's correct. Yeah.
Yeah. And anybody who's been in Power Automate or the Power Platform in general, there's a lot of stuff that kind of all works very similar. But yeah, that's a good point. It's pretty much same technology. Another question we have is what other, maybe this is more for Amanda, are there other use cases that you can think of off the top of your head that some of the stuff you're showing off might benefit from.
Yeah, so we were talking about towards the end how some of these capabilities can be used for medical consultations or sales calls. I mean, with sales calls, you can use natural language understanding models and Lewis to understand what a potential customer or partner might be looking for, and you can help make that a more seamless conversation. You can also maybe train a natural language understanding model on the conversation that you're having with a potential sales partner or customer to understand, what words are maybe working to make this pitch go better, and use that to improve overall how you train your sales teams.
Yeah, and Devanshi, do you have any other examples that you can think of as well?
Yeah, I was just going to say, so another thing you can work on is, let's say you're taking a bunch of Twitter tweets and you're trying to figure out what the main key phrases are, what the main topic is at hand. So you can take a popular hashtag, right? Let's say climate change, and you want to see what are the main topics that are being talked about within climate change. And so you would just use the text analytics API that Amanda showed, extract the key phrases, and there you go. You know what's being talked about.
Yeah, no, I love that. I actually saw a demo yesterday from another cloud advocate that uses text messaging, some SMS, and does sentiment analysis on that text messaging as it comes in, just to sort of clarify, I think, the way this person and another person communicate. I think there's some vagueness there. And so anyway, it was just a fun project to try to like cut through the cruft and actually figure out what does this person really mean. So this is really great stuff. What other types of stuff, Amanda, or what other things should people go explore who are curious to learn more about Lewis and the things that they can do with that?
Yeah, well, we definitely recommend that you start with the Lewis interface, lewis.ai. We also have lots of other cognitive services documentation about the different offerings with speech. We're coming out with something where Lewis can analyze perhaps longer sentiments and be plugged into maybe even calls so that it can be processed in real time. So definitely stay up to date on what's coming on the horizon.
Excellent, excellent. Well, we've got another talk coming up here momentarily from Amy Boyd, who's going to go into unstructured data with AI. You can start to see a theme through these first three talks already in that it's all about data, right? It's about going in and understanding what do we have available to us. The world as we know it now is just generating more and more data constantly, and making sense of that data. It seems to be really the overarching goal of AI and a lot of the things that we're going over today. It's not to take anybody's tasks away necessarily. It's not to take any jobs away. It's to kind of create other new scenarios for more folks and enable more people. So thank you so much for everything that you showed off today. Devanshi, thanks for jumping in and answering a few questions for us and adding your input. I think we're going to switch over here momentarily, or maybe now, and just go ahead and bring in Amy, our next presenter, and let's just go ahead and get things kind of back on schedule. Amy, how are you?
I am good, thank you. Enjoying the sessions. Oh my goodness, how is it the third session in already?
Already, right? We're moving right along. The last two sessions were great. Amanda's talk just now was spot on, perfect, just like we expected it to be. Yes. So far, let's just pause here before we jump over into your talk, because I want to chat with you for a minute, because you've been instrumental with this whole event, this All Around Azure Developers Guide to AI. We mentioned at the beginning of the show that we had our sessions over in the sort of the Asia time zone, and we had stuff over in the European time zone, and now we're here in the Americas time zone. And a lot of that has to do with you sort of pushing to make this happen. So thank you for all your effort in putting this very first All Around Azure global event together. It's been great. We've got some really great engagement, a lot of conversations happening in chat. Join us over at Learn TV. Drop your questions in there. And we are going to save all questions for Amy's talk to the very end, like we did with Amanda. So Amy, I think I'm just going to go ahead and let you have the floor, give you a little extra time to get through it, and then we'll watch for the questions and we'll address those at the end.
Amazing. Thank you so much.
Good luck.
Thanks. So yeah, as Jason just mentioned there, I have a lot to talk to you about, so it's probably a good thing we have a little bit more time. But yeah, I want to tell you a bit of a story. So we're going to go through a bit of a story. I'm going to go through some video demos of the kind of full process, but please ask your questions. Really keen to answer them towards the end of the session. So welcome to this session. We're going to talk about making sense of your unstructured data with AI. I'm one of our cloud advocates, as with our other speakers, and we are going to talk through a business scenario using unstructured data and applying AI and search services to actually solve this business problem. So let me first talk a little bit about the business problem itself. Tailwind Traders are a fictitious retail company. They deal with DIY, do-it-yourself goods. They have shops and stores all over the world, actually. I was about to say a country, actually all over the world. And one of the things that they're finding is their invoices are in this format here. So what you see on the screen, we've got a few examples, and then I've kind of like zoomed in a little bit on an example. All of this data is in a PDF, and PDFs can come across as being actually really hard to extract data from. What Tailwind Traders want to get from this is they actually want to understand where this invoice came from, what date, what was the actual total amount, who bought a gnome from Tailwind Traders in Australia, for example. That's the kind of detail that they really want to go into, but they're currently in this PDF scenario. Also, one thing to note, this is one of the stores, has invoices dating back to 2008 in this kind of folder structure. And if you take a look at how many files there are 140,000 files. And this is just one of the stores. So one of the key things we need to solve here is all around automation in order to gain efficiency. The Tailwind Traders technical lead heard about search as a service on Azure. So what is that? That is a service called Azure Cognitive Search, a set of developer APIs and tools that allow you to build a really rich search experience over your heterogeneous data. So let me break down those terms a little bit. Search experience, literally thinking like when you use a search engine, but say on your organizational data itself, not on kind of like public data. Heterogeneous data is all of those different data types, a bit like what Amanda spoke about. We're talking images, PDFs, files, structured data, unstructured data, all sorts of different things. And so the idea is basically using cognitive search to break down some of that content and understand what's going on inside it. So let me explain how Azure Cognitive Search actually works. First of all, we're going to take a data source. Our data source is going to be our Tailwind Traders PDFs. We're going to do something called document cracking. So cracking is basically opening up that document and understanding what's going on inside. So rather than just metadata, file name, file size, etc., actually understanding what is going on in the content. Once we have this document cracked open and we know that there's content inside, we can actually apply something called skill sets. Cognitive skills can use the Azure Cognitive Services, so all the things we've seen before this, image, text, speech, etc. But you can also build your own custom skill sets to do any kind of processing that you wish. Once you've applied all these, you get this enriched document, this document where you know what's going on inside of it, but you also know about all of its metadata. And having all of that metadata actually allows you to then have this search index idea. So I want to be able to search for all the PDFs invoices from Australia, or all the ones that include a gnome, for example. Not sure why I'm stuck on the gnomes here. Okay, before we dive in, because there's a lot of demos that I want to show you, I want to talk a little bit about the architecture. AI never sits alone. It's never just one single service. It's built into an architecture. So we're going to have our PDF invoices stored in an Azure Blob Storage account. We're going to actually connect them as a data source to Azure Cognitive Search. Cognitive Search is going to have a skill set that points towards an Azure function. This function is going to call the Azure Cognitive Services, and specifically the Forms Recognizer API. Really excited to show you that, some really cool stuff there. It will pass back all of its information back to the Azure function. The Azure function will do some pre-processing, so it will tidy up what we get back from that API, and pass it back to Cognitive Search to actually bring together the data, the skill set, and the index. Once we've processed all of those PDFs, the full 140,000 PDFs, we're actually going to store it in something called a knowledge store, which is an Azure table storage. And then finally, the key point on the end is actually creating that search interface. So either building an Azure app service or building it into the applications that you already have so that your users or your customers can actually start searching across data, or something like a business intelligence tool. So first things first, we are going to cover a lot here. There's going to be a lot going on. We're going to go into some detail. So visit aka.ms/AIML30 for you to go and get hands-on after this session and really dig into the concepts that I'm going to cover. So let me just drop over to our demos here. Okay, so here we have a PDF, Tailwind Traders PDF. And one of the things that is really, really great about this is I'm actually able to see all the different values and stuff like that. Inside Azure, I've created an Azure Cognitive Service instance for forms recognizer specifically. So this is going to analyze and extract key value pairs from our PDF, and we're going to call it by using the endpoint and the keys for this service. So now we have our instance in Azure. We're actually going to go over to something like Visual Studio Code. So in my case, that's what I'm going to use, but anything to call an API. And I'm going to use some curl statements in Visual Studio Code to actually retrieve training results and analyze new forms. So let's zoom in a little bit here. Do go into full screen mode for this bit if you wish. The train model basically calls off to the API. So the forms recognize the API in Azure, and it calls the custom models part of that API. We're also going to pass it JSON data. I'm going to pass it also my key, so I know I'm interacting securely with the API. And then the other thing I need to pass it is the source of the data. So what I'm going to do is I'm going to head over to Azure Storage Explorer, and I'm going to select in our training data set the whole container and get a shared access token. So the shared access token means that the service can actually access this data. It has permissions to. And what you'll notice is we have 5 different PDFs in there. So I'm going to take this curl statement and post it in. What we're going to see is we get a 201 created and kind of lots of other information. But the key piece is this URL, because now this ID at the end of the URL is our specific forms recognizer model. So it's trained on Tailwind Traders invoices. Now we need to retrieve the training results. I'm not just going to trust what the terminal tells me in this case. So I'm going to pop my model ID into the API query. And then all we need to provide is the key for this piece. So I'm going to pop that into the terminal, and I get the this JSON response back. Now, JSON's quite hard to read, I always find, in the terminal. So what I'm going to do is I'm going to copy this, put it into a JSON file, and use Shift-Alt-F. Shift-Alt-F is my favorite Visual Studio command to format JSON. And what we'll see is you've got lots and lots of invoices that I've trained my data on, and they say succeeded. But we don't just want to stop there. We want to know whether this actually works for data it's not seen before. So what we're going to do is we're going to analyze a new form. To do this, we need to fill in a few little gaps in our statement here. So first things first, let's take that model ID, so the Tailwind Traders invoice model specifically on our data. And I'm going to get some source data again. This time, I'm going to use the test container because I don't want to pass it something it's already seen. I've got a lot of good examples in here. So let me copy another SAS token for access. And I'm going to take this statement and pop it in the terminal. Lots of stuff going on there, but basically it's run. And then what we really want to do is get back what did it extract from our form. And so to do that, we're going to use this get results. We're going to pop in that model ID. And again, just like previously, if we look at what it returned the model ID, then analyze results / and another ID. So we'll put that in our result ID. We'll take that statement. Well, lots and lots of JSON here for us. So my favorite command is in order. Shift-Alt-F was going to give us some great formatting. look at the size of that document over there on the right. So this is all the key value pairs that the forms recognize actually extracted from my invoice. So it took out name, name was Brian, it took out address was 1145, but it also takes out every bounding box, so the actual space on the screen where it's being used. So we've trained our forms recognizer, but how do we integrate it into our cognitive search experience? Well, I've got some sample code here inside Visual Studio Code. This sample code is from the Azure Cognitive Search Power Skills GitHub repository. They've built some amazing sample code that's specifically for forms recognizer to build it into Azure Cognitive Search. So I took this code as kind of an idea of best practice. And all I need to do is basically change some of the settings. So I'm going to provide my forms recognizer, my cognitive services, endpoints and keys, as well as that model ID. So the model ID that's trained on Tailwind traders. And then in field mappings, this is the only data that I want it to provide back to Azure Cognitive Search. I don't need the bounding boxes. I just want these key value pairs so that I can search across that data. So let's run this code. And actually, one of the nice pieces here around Azure Functions is I can actually run this locally. If you notice, this is a local host API / analyze form. I'm going to take that and pop it into Postman. Postman's another great way to call REST APIs. And all I need to do is then provide it a form. So a bit like what I did when I trained and test the API. So I'm going to get a different form this time and grab the URI. Let's pop that into Postman. So what we'll see is the URL is there, but I'm going to take the SAS token off the end and actually put it in the segment below. So it's definitely got what it needs here, and click send. And now what we see is we've analyzed this data, but all we get back is not all that, huge file. We just get what we need back. So the function has done some great pre-processing. Just to note, gives you some good stuff in the terminal to when you're debugging. This was really useful to actually tell you that it's extracted everything. Now, I don't want to stop there. I don't just want it to be on my machine. I want you to all be able to use it as well. So I want to put it into an Azure function. We've got the same code here, but I click on the Azure icon on the left, and we can see I've created an Azure Functions instance. So you can do that by just clicking Deploy to Function app. It's such a good, quick experience. I'm not necessarily an app developer, so this was a treat. It asks me for things like name and location. But also, one of the other pieces, Seth's going to join us actually shortly to deliver a different session, but he taught me about this application settings. So if you open these settings, what you'll notice is all my forms recognizer pieces, that I put in that local settings.json file. I can click upload local settings, and it will just take those settings across and push them up to the cloud. This is great. This means no keys in code. This means everything's stored securely in Azure. So this is what it looks like in the Azure portal. I've got these functions here. We can see that I've got a URL to call my function, and it's /analyze form, just like it was on the local host. One of my really nice pieces here was actually testing this. I felt good because it was inside the actual portal, so I knew it was definitely calling this one. And then you can do a post request. We can see it's exactly the same format as it was on my local host, but when I run it inside the Azure portal, I get the same output. So it's analyzing the form, it's provided me that feedback and just the data I need. So that's a really simple way to quickly check that it's doing what I expected. Okay, last step. I hope you're still with me. We have not even gone into Azure Search yet. Now we are in the Azure Cognitive Search service. And there's multiple things going on here, but basically this is going to connect everything together. So we have things like data sources, which is our blob storage. We have skill sets, which is our function. We're going to create an index, and the indexer is the workhorse of the hour, basically. So to do that, all you do is call APIs. So we're back in Postman again. We're going to add our skill definition. So our skill is our Azure function, and it calls off to our forms recognizer. So it extracts data from our PDFs. I'm calling off to the skill sets API and calling it forms recognizer skill. What I'm going to do is also provide it, just tell it it's a web API skill, and this is the URI I want it to call. So this is my functions URI with a token for secure access. I also tell it what the input schema looks like, which is my form URL and SAS token, as well as what it should expect to bring back to Azure Cognitive Search. So that is all of our key value pairs that are very neatly formatted for us by our function. So let me send that off. We can see it's 201 created. There's some good stuff in there, but I actually like going back to the portal. If we go into skill sets and click refresh, we can see I've got this forms recognizer skill with one skill. So that is call off to my Azure function, and my Azure function does the rest of the job. Okay, so we've got our skill set in place. Next up is our index. Our index is our schema. Think of it like that. What should Cognitive Search store in our knowledge store? What should it be extracting from the data? And what should we be able to search on? So we can see we've got our metadata at the top, but then we have our key value pairs all described at the bottom. Also note, you've got these other assets, so filterable, retrievable, searchable. These are important for the front end. When you're actually starting to search over this data, you can say what should be in the filters that you want to have people filter from, or what you want to actually be brought back, so what's searchable. So I send off that index. I can see my invoice is here. It's got no documents in there at the moment, but we're going to combine our data source, our skill set, and our index here, and it's the indexer. The indexer, as I said, is the workhorse. It's the piece that pulls everything together. So let's create our indexer. Same API, slash indexers. We're going to call it our forms indexer, so watch out for that in the portal. We're then going to tell it what is our data source, what is our index name, and what is our skill set. So bringing all of that together. We're going to tell it what are the input mappings, but more importantly, what are those output mappings? So those key value pairs from all of those 140,000 different forms. So this is at scale, right? This is automation at scale. So we've got a 201 created. We click on our indexer and we see our forms indexer. It tells us it's in progress, right? This could take a little bit of time. So if we refresh, we see it's now done 10 documents. So it is processing, it's doing a good job. Finally, we refresh again and we can see it's completed all 20 documents and it was a success. If I go into my index and just quickly refresh there, we see we now have the 20 document count. So that was my sample set of documents. And I can simply just search over these really quickly. So you can see here, we've got like the kind of messy, just pure content that was extracted just there. It's not like super useful to break down, but look at this nice, tidy key value pairs that I can search over so easily. For example, I only want data from Australia. I was talking about the people in Australia buying gnomes. So this is exactly how you can start to search. I'm doing this in the portal, but think about how this could be used if it was on, say, something like an Azure web app. So to wrap it all up, we covered so much there. That was not obviously real time. That takes a bit longer than the 12 minutes, I think, of demos that I have there. But I wanted to highlight on our architecture where each of these elements sits. So our data source is our blob storage. Our skill set is our function. Our index is actually the data that ends up being in our knowledge base at the end. And the indexer is cognitive search kind of center that pulls everything together. One thing we didn't cover in this was the front end. So actually being able to search over it. However, there's lots of great content out there that will show you that, including our amazing Microsoft Learn module. So if you go to aka.ms/AIML30, you can go and get hands-on. It's a slightly different topic, but you get exactly the same idea. And when you get in there and get hands-on, it all kind of pieces together, which is great. Little certification alert, go to aka.ms/AI900 to check out the AI Fundamentals certification. And otherwise, Jason, how was that? I probably went over, apologies.
No, that was amazing. You didn't go over it all. Well, no, we're good. Yeah, actually, I had to like bend over and pick up my mind because you just blew it with everything that just happened. Like it just like blew me away. There's people on the stream for sure right now who are feeling the same way, because you just demonstrated that no longer do I need to manually read through a stack of documents and get those made sense of and put them in the right place. And like, there's a solution for it now. And it sounds like you definitely need to know JSON. You know, there's a lot of tools in there. I'm joking about the JSON, but there's a lot of it in there. You know, that Alt, what was it? Shift Alt F, I think is the secret weapon in VS Code.
I don't even know who told me that, but I think Microsoft Developer like recently tweeted about that, and they were like, "What's your favorite like shortcuts?" And I was like, "Oh my god, Shift Alt F, like definitely."
Right. Exactly.
Especially when dealing with all this kind of stuff.
If you have any takeaways from today, it's maybe try Shift Alt F if you're always doing JSON and VS Code. So there's a couple questions.
Modules, Shift Alt F.
Yeah, exactly. So we had a couple of questions that came in over with our audience over at Learn TV. First one is really just, I think, a general question for today's events and in general is recordings. Will there be some place that we can go and watch everything that took place today another time?
Absolutely, yeah. I believe the Japanese and French events are already available on YouTube because they were live broadcast. But we will be putting together all of this content and we will make it available on one of our Microsoft channels. If you have registered for the event, so if you went to aka.ms/allaroundazure-AI, you'll also get a follow-up email and it'll have links to all this content in. So even if you didn't register, I think you can still register now. Go do it just to get the comms afterwards with all the great URLs.
Yeah, exactly. We definitely want to make all this stuff available for those who weren't able to join us today. Another question we have from someone, Mike, over in Learn TV is, how does ACS handle changes in data structure changes?
So I'm going to interpret ACS as Azure Cognitive Services. I was going somewhere else. I was like ACI. I was like Azure Container Instances. I was like, I don't think I went
that's
there.
Where my mind went too.
I covered a lot, but that wasn't in there. How does it change? How does it handle, data changes?
How does ACS handle changes in data structure changes?
Yes. So for forms recognizer, this comes up a lot. So you only need to train your model on 5 forms is the minimum in some senses to actually get it to understand the layout. So if you have multiple different types of forms, I believe the best practice is to make multiple different models, right? Your model is then trained. It has an ID that you can access. So say you were doing the processing of this and you can actually then have okay, I want to run all these types of forms in Azure Cognitive Search from this data source, and that it will use skill set X. And then I'm imagining, okay, then I have like this legacy form or like a different type of form, and it will then do a different model. If the data is different, so say like instead of name, address, and someone bought a gnome type thing, if it's how it was actually something completely different, like a HR form for Tailwind traders, they need to be trained differently. If the data in the actual invoice, for example, it's not a gnome, it's a hammer, that's fine. It will understand key value pairs and format, but if there's changes in forms completely, like the structure, I train another model.
Okay, great. Hopefully that answers our question for our guests there. One other thing that I guess wanted to point out, or maybe just jam on for a minute while we're setting up for our next talk here, is you showed the ability to do things locally and then push up into Azure. Could you maybe just expand a little bit more on what's happening there? Yeah.
So what I did was where obviously, well, I'm gonna air all my dirty laundry here. When I code, it does not work first time. There we go. I've said it live on air now.
It never does.
It absolutely does not work first time. And so one of the really nice things with Azure Functions, I've only recently got into it. As I said, I'm not like a hardcore app developer. I've obviously done a bit of that in the past, but realistically, I focus more on AI. The functions inbuilt packages and tooling, inside Visual Studio Code is really, really nice. And so actually what you can do is my function is just running a segment of code, right? It's just fire this function, run a piece of code. And so my code called off to things like forms recognizer, and obviously I have internet connection on my local machine, etc. But being able to test it locally was so good, rather than being like, well, Damien on our team would be really upset as well if I right-click deployed without like testing. I know. If I did that, like it would take longer as well. And all I want to do is I just want to test. So especially when I was building, it was really important to like build that function up over time, edit small bits of it. So I changed the field mappings and I changed the keys. And as I said, doesn't work first time. So that runs locally. And then I pushed it up to Azure Functions once I knew that it was doing what I wanted it to do.
Excellent. And that's really, it really is a deployment of the Azure function into an app service type of thing, I think, within Azure. So yeah, very cool stuff. I love that I can work locally. I mean, I typically have internet connection all the time, but there's more and more ways lately where I can actually disconnect, still work on some stuff, and then later when I'm ready to reconnect. So thank you for pointing that out and highlighting that. So we've got we're a little over halfway. Can you believe that through the event for today?
Oh my goodness, it'll be really sad when it ends. This has been my thing.
Yeah, it has been a thing that we've been working on you heavily for quite some time. So thank you for all your hard work. We've still got 2 more talks coming up. 2 more presentations. We're going to be talking a little bit about conversational AI, I think, with our next one.
Session.
Yeah, we've got Gary Purdy coming up, and that's going to be amazing. So stay tuned for that. He'll be joining us in just a moment. And then following that, we'll do a Q&A, of course. And then we got Seth Juarez, right? I believe right after Gary. Seth's going to be talking to us about some machine learning stuff, of course, but how to make your models faster, right? Is sort of the premise of that.
Yeah.
Excellent. So I'm really excited for that. I say we maybe, if Gary's ready, we can go ahead and bring Gary in and just tease a little bit about what we're going to be talking about. And in the meantime, we can also answer any more questions. If you have some, please drop those into chat over at Learn TV. Gary, how are you?
I'm doing well, thank you. Yes,
welcome to the show.
Be here. Yeah,
yeah, we're really excited to have
you. Great session, Amy.
Oh, thanks, Gary.
Yeah. It was amazing. Gary, tell us just a little bit about yourself before we go into the contents of what you'll be presenting on.
Yeah, so I'm a program manager on the Conversational AI team at Microsoft, formerly an engineer on the Bot Framework team. And so today we're going to be talking about how we can solve real world problems, some of which are pretty heightened in the current times, using conversational AI.
Excellent. And when you say conversational AI, I feel like there's a lot of ways that could go. So we're talking more chat-based type of conversation. Is that correct?
It could be, right? Conversational AI is effectively allowing humans and machines to talk in a more natural way, and that is and has been more commonly via text and chat-based, but more and more we're seeing, as we've heard in previous sessions today, things like call center-based scenarios where it's speech via telephony or whether it's via one of the home assistants.
Right. Yeah, and the idea of talking to something within chat, within wherever it may be, and it responding to you, I think is the idea of science fiction. So things that, robots, right? That if you say, hey, can you provide dinner for me? And next thing you know, you got dinner. Right. I spent a great deal of time thinking about, writing about, talking about this idea called chat ops, which is very similar. It's just really taking tools that you already have to solve problems and then dropping them right into where you have your conversation. So you got your apps, you got your bots, you got all these different things that just sort of work on behalf of you, triggered in certain ways. And so I feel like there's a very common ground for a lot of the things that you're going to be showing us today, and just the overall topic of chat ops. Now we're going to bring some intelligence into those bots. So with that, maybe we can go ahead and pivot and let you take the stage and go from there.
That sounds great.
All right.
Fantastic. Thanks so much. So yeah, thanks everyone. And in order to talk about conversational AI today, we needed to pick a topic, a scenario for us to actually start to dive into. But one thing I really want to highlight is that the technology we're going to see here could be used anywhere. Really, the possibilities are pretty endless, and hopefully this session is designed to give you an insight into what's possible, show you how we can really make something quite sophisticated very quickly. And I'll be delighted. Please drop your questions into the chat, and we'll definitely answer as many of them as we can at the end. So today we're going to focus on a scenario again with Tailwind traders. Tailwind traders have recently surveyed their employees, and they want to find out how employee satisfaction is, and where people are happy and where they are not so happy, and where things could be improved. And the good news is all of the employees internally think their career progression options are fantastic, but Tailwind traders have the same problem that many enterprises and businesses out there have, which is the employee experience, certainly now in times where we're working from home, is not fantastic. There's still plenty of cumbersome scenarios and processes that you need to either print something out, fill it in, sign it, send it off to somebody else to be approved. Maybe it's via email. And actually, they're just not happy with these cumbersome processes, which are just made harder in the current climate. So they're going to try and use conversational AI to solve these problems. And really, let's just land on a definition of conversational AI before we go any further. And this is one of the definitions that I quite like. But essentially, we're talking about humans and machines interacting in a natural way. Gone are the days where I should have to buy a book to understand what the exact syntax is, the exact commands to type into a computer to have it understand me. Now we just expect, and more users and customers are expecting to be able to interact with computers in the same way they interact with their friends, you and me, and colleagues at work. And Microsoft has a phenomenal conversational AI platform to allow us to build robust, sophisticated solutions to actually answer some of these problems. And you're going to see some of the services that we've talked about in previous sessions today, again, coming into the picture for conversational AI. So let's look at it end to end. Everything starts with some user input. Traditionally, as we were just talking about, that can be via text or speech, but it doesn't have to be. It could be via video, it could be via images. It really, as long as you can input and you can send that data to an application, then we could accept that as input as part of a conversational AI solution as well. The next thing is the channels. And one of the services we're going to talk about today is Azure Bot Service, which allows you to create conversational AI applications and surface them on multiple channels. Those channels could be internal facing, like Microsoft Teams or Slack, or they could be external facing for customers, such as a web chat on a website, or even one of the home assistants, such as Alexa. Then we need to actually build an application to sit behind one of those channels for our customers and users to actually engage with. And in this scenario that we're going to talk about, our customers are the employees of Tailwind traders. Everything that you're going to see is built on top of the Bot Framework SDK. That's actually available in 4 languages for you to actually build code-first solutions if you wanted to. And if you've used Bot Framework in the past, there's every chance that you've built a code-first solution already. But actually now, we actually have 2 awesome solutions within Microsoft to allow you to build conversational AI applications incredibly rapidly and really build up some sophisticated logic. The first one is Power Virtual Agents. It's part of the Power Platform. This is really well suited for business users and citizen developers. It's a no-code solution. And thanks to a release just earlier this week, we've increased the options for you to be able to extend that using our second option, Bot Framework Composer, which is our integrated development tool for developers. And it allows you to create, edit, and test conversational AI applications incredibly quickly. Connected to that, as I said, are the cognitive services. Really, the Bot Framework SDK is allowing you to, it's like the orchestrator for conversations, but then we add cognitive services like Language Understanding Service, or LUIS as is more commonly known, Q&A Maker, and the speech service to actually add intelligence to our solution. Okay, so now I'm actually going to dive into a demo. And we're going to jump over to Bot Framework Composer for us to really understand how we could start to build out some functionality that will help Tailwind traders' employees. And if you are struggling, I've zoomed in already. Please do go full screen if you would like to, if you need to see this content. So I'm here in Composer. I've created a new bot, and I've already added some functionality to it for us to walk through this, just in the interest of time. The first thing to know is that bots built with Composer are built on a trigger and action paradigm. So you will have one or more triggers, which I can add up here for adding a new trigger. And triggers are a way for me to respond to external events, such as a message being received and that triggering an intent being recognized, and this is the integration with Lewis. Or maybe it is somebody joining a conversation or a custom event being received. Whenever you create a bot inside of Composer, you'll always start with the greeting trigger. The greeting trigger is fired and executed when somebody joins that conversation. The next thing to notice are actions. These are actions that are listed here on my canvas. And I can have one or more actions for each trigger that define what happens with my conversation when that trigger is fired. So in this case, the greeting trigger fires when the user starts the conversation with the bot, when they join the conversation. And essentially, I'm sending a welcome message back to the user. Over here on the right-hand side, you can see that I'm actually specifying the text for this sender response action to use. And I'm using something called LG, or language generation syntax. And you can see here that I've actually specified two different variants of the same message. And I've done that for a really specific reason. Traditionally, chatbots could actually feel quite stale and samey if you use them over and over again. And we can actually use LG to specify multiple variants of the things that the bot will say to make sure that actually, if you use it more than once, the bot will actually pick one of those variants at random and make the conversation feel more fresh and more natural for people who are using it over and over again. Composer also has other types of actions that we can add, such as asking open questions, using multiple choice, date and time prompts, etc., and even accessing external resources, such as sending HTTP requests. Over here on the left, I've got another trigger, the help trigger. And this is using one of the more common types of trigger. This is the intent recognized trigger. And this is going back to Lewis that we saw in an earlier session. And over here on the right-hand side, I've specified trigger phrases, examples of what a user might say in order to help me indicate that that intent has been matched. And we'll actually take all of the trigger phrases for each of the triggers that we've created, and Composer will automatically create and publish a Lewis model for you. When I'm ready, I can click Start the Bot. I've already started it here. And when I start it, it's going to ask me for a Lewis key, which I'm going to populate. And once I've populated that Lewis key, it will create that Lewis model, start my bot, and it's ready to test locally. I can then switch over to the bot framework emulator, which you can see in front of you now. So I've started a conversation with the bot. Let's restart it. You can see here that I've received a conversation update event, meaning the user's joined. It's fired my greeting trigger, and it's presented me with the welcome message. You can see here, it says, "Hi there, I'm the Tailwind Traders Employee Vacation Assistant." If I restart that, now it's picked a different one. It says, "Welcome to the Tailwind Traders Vacation Assistant." I can just type help if I want to, and the bot's going to trigger a different trigger. It's going to trigger that based on a call through to the Lewis service. The Lewis service is going to understand that the help intent has been matched, and it's going to fire my help trigger. And the help trigger will then send this response and execute the actions that it needs to. Another thing that it's worth noting is I can take one or more of my actions that are on the screen, and I can group them into what's called a dialogue, such as this dialogue here, book vacation. So this book vacation dialogue is designed to allow a Tailwind Traders employee to raise a vacation request rather than going through the traditional sort of paper-based approach. They want to be able to just do it wherever they are, whether that's in Microsoft Teams or Slack or any other platform. Here I'm using a number of different prompts, such as date and time, and multiple choice, for example, to actually collect the information from the user. So let's go ahead back into the emulator and have a look at what that looks like. So I can go ahead and say book vacation. That's going to match the book vacation intent, and it's going to ask me for the start date. Thanks to the built-in recognizers within the Bot Framework SDK, I can actually say things like tomorrow, and that's automatically going to resolve the dates out for me. I can specify when my vacation ends. I even get suggested actions based on because I'm using a multiple choice prompt. It's providing me with suggested actions, so I don't have to type everything. We're trying to make the input the most appropriate and the most efficient for the user. Here it's asking me if I've got any comments that I need to leave with this vacation request, but actually I made a mistake. I said no. It's now asking me whether or not all of the details are correct. Now, traditionally, I would need to answer yes or no in this instance. If I didn't answer yes or no to a bot that was built maybe with some older technology, it would just repeat the question and say, I didn't understand. But it would be much more natural if I could say something like, change my comment, amend my comment to something else. So how can we achieve that using Composer? Well, let's switch back over and I'll show you how straightforward this is. If I look at the prompt for confirmation here, and I switch over to the prompt configurations, you'll see that I've enabled a setting called allow interruptions. And if I set allow interruptions to true, that means any one of these triggers over here on the left-hand side could actually interrupt and take over the conversation temporarily, execute their actions, and then have the bot resume back on this confirmation prompt. And that allows me to implement a nested trigger. So I've created another trigger here called edit comment. And edit comment has trigger phrases like change the comment, edit the comment. And you can see here, I've even started to add things like simple machine learned entities, which you can add within a Lewis model to allow the user to even say something like change my comment to long weekend. So what's going to happen is at the point at which we show the confirmation prompt, if this trigger gets fired, it's going to ask the user for what they would like to change the comment to. But we're going to check if they've already stated their new comment as part of their phrase. And if we have, we'll skip over that prompt. We will store that new comment over the top of the old one that the user entered, and then it will jump back into the confirmation prompt as part of the book vacation dialog. So really, it's taken me a couple of minutes there as a developer to actually implement this scenario. I can jump back in here and I can say change the comment to long weekend. Do that, and then what's actually happened there, it's reprompted me. It realizes I've already specified long weekend as part of my initial phrase. It's updated that, and now it's reprompting me. I can say yes, and it will go ahead and book that vacation for me. Okay, so that's fantastic. I've now got the ability for my Tailwind Traders employees to book vacation as part of their dialogue, as part of the bot. What I'd like to do next, though, is actually start to surface information that we have within the Tailwind Traders FAQ page. This is all information that employees have to right now. They have to navigate to the intranet, they have to find the FAQ page, and then they can start to browse through those questions to see if they can find an answer. Well, actually, there's a service, a cognitive service called Q&A Maker, which can actually take the contents from this FAQ page and turn them into a conversational application. So if we switch back over to Composer, I can actually add another trigger, and this time it's a specific trigger. It's a knowledge-based trigger. I could give this knowledge base a name like Q&A, and here I would paste in the URL to that FAQ page. And when I click Create KB, that FAQ page will actually be extracted by Q&A Maker and will store all of those questions and answers for me right here inside of Composer. I also get additional capabilities that Q&A Maker offers, such as the ability for it to add additional alternative phrasing to help the training. But just like Lewis, when I start the bot, it will actually go ahead and publish my Q&A Maker model for me up into the cloud. Previously, you would have to move between the Q&A Maker portal, the Lewis portal, and your code inside your SDK-driven bot. But now, using Composer, we try and make sure that you can stay within the context and stay within your flow when you're building your conversational application. Now that I've done that, I can go back to my bot and I can type in something like, what does WOB mean? And the bot will go and query the Q&A Maker model, and it will come back and present me with the answer, work on behalf of. And you can see here now how the trigger and action-based approach really is effective for building a multi-talented conversational AI application. Depending on the message that I send and the recognition from Lewis or from Q&A Maker, or whether or not it's a particular event like a user starting a conversation, really drives my my conversational application and allows me to handle things like interruptions and context switching in a way that I just haven't been able to do before. Okay, when I'm ready, I can switch over to the publish section within Composer. And here I can actually publish out to an Azure web app, Azure Functions, or even with the latest update this week to Power Virtual Agents, where we can actually extend Power Virtual Agent solutions using Composer. I definitely encourage you to check that out if you've used Power Virtual Agents in the past. Once you've published out to Azure, you can switch over here to the Azure portal and your bot registrations resource, which is created for you when you provision your resources. And here it's really straightforward to start to enable channels like Alexa or Slack or other channels like speech. And here I could click Teams if I wanted to. I get the instructions for enabling that channel and how I can publish out to the Teams application store. And within minutes, I can be chatting to my bot in Teams. Okay, so let's switch back to the slides. So we started off with a scenario where employees were happy about some things, but they were struggling with some of those more common, more cumbersome processes. We've solved that problem by implementing conversational AI. And as Jason said before, really meeting the users where they are, allowing them to interact with the bot on any channel where they normally converse with other people, meaning they don't have to break out of their flow. Just like we don't have to break out of our flow when we're using Composer and we're integrating with Cognitive Services. You can find out more about Composer and get started by visiting aka.ms/try-composer. I'd really encourage you to do that. We've got some phenomenal new features in the latest release, and we've got lots more planned for the coming months as well. You can also check out aka.ms/AIML40 for an MS Learn course around bot framework. You won't find Composer in there yet, but we do have some. We do have another module focused on Composer, and we do have some updates planned to that content as well. As we've called out in the previous sessions as well, check out aka.ms/AI900 for the Azure Fundamentals course. A fantastic certification to get hold of. So definitely encourage you to check that out. And now we're going to head right back over to Jason, I think, for some Q&A.
That's right. Awesome job, Gary. That was amazing. As expected, blew me away with all that chat op stuff. Like I mentioned at the beginning of the presentation, it's a topic I've spent a lot of time working on, and very little with a lot of the, the Azure Cognitive Services and the different things that you demonstrated today. And man, my mind was just spinning with ideas. Like I have so many questions for you. But before we get to my questions, let's answer some of the questions from Learn TV's chat. First of all, we got a question from Mike. Where is the data stored on your vacation bot? How does that data get moved around? Where's it saved?
So interestingly, with some solutions, when you're building AI solutions, for example, quite often your data might be stored in the cloud and you don't necessarily have access to it. With Composer, we really wanted to avoid you hitting a cliff, right? There's a lot of solutions out there that have a visual designer that allows you to design something, but then if you want to customize it, you have to completely change track and then go build something separately using the SDK. Composer is just a layer on top of the Bot Framework SDK. So as you're designing your conversation and your dialogues that you saw me handling there, and you're creating your language models, we're actually creating a real SDK bot on disk, and all of your language models are actually stored in Markdown-like files, and they get used, transformed, and pushed into the cloud when you start your bot.
Okay, that makes sense. So another sort of, I guess, follow-up question to that is, as far as follow-up from our guest, Mike, is it possible to integrate with Power Platform in the stuff that you demonstrated? Nope, we muted you. Hang on.
Let's try that. Don't ask me how that happened. I'm talking away myself. I hadn't even noticed. Right. Yes. Power Platform. Let's reset.
Yeah.
So Yes. As I said earlier, we've got two options. We've got Microsoft Power Virtual Agents right now, which allows you to go and build conversational applications. And we have Bot Framework Composer. Both great options, depending on which audience you come from. Again, we are very, very focused on making sure that there are no cliffs. So if you start in Power Virtual Agents, which is awesome, you can now actually extend that into using Composer directly to actually add extra functionality. You can also take any bot that you build inside of Composer and you can turn it into what we call a bot framework skill. So any bot can be a skill. And that means that you can actually have this like parent-child type of functionality where my Power Virtual Agents bot can call out to my HR bot as a skill. So you might have a single front door for all of your employees, and then have one team build a bot using Composer, have that as like an IT bot built and expose that as a skill, and another team build a HR bot and expose that as a skill, really allowing you to democratize the ability to develop these solutions across the organization.
Excellent, excellent. So yeah, we can have multiple bots that all sort of talk to each other, I guess you could say.
Right.
So
Exactly.
we spent a lot of time going over Composer, awesome tool, but you also mentioned the Power Virtual Agents as a no-code solution. We didn't really demo too much about those. I get the impression from the Composer, it's somewhat no-code. I mean, there's it's a nice interface where you pick your triggers and your actions, very Logic app-like, I would say, Power Platform-like. What else can you tell us about the Power Virtual Agent that is? Why would we choose to use that? Why would I go explore that model or that tool rather than what we showed us?
Right. So I think it depends. I think if you are a business user, or let's say maybe a less technical user, you're not a developer, Power Virtual Agents is a great place to start because there is, you definitely have more, you're on more rails with that experience. There's still plenty of power there, but really they are surfacing the key scenarios that we need to build the most common type of tools. I think another key thing to point out here is that Power Virtual Agents, because it's part of the Power Platform, has incredible links to the rest of the Power Platform, things like Power Automate, etc. So that's a great place to go for building many conversation solutions, especially if you want to hook into things like Power Automate. Composer will do many of the same things. We have many of the same ideas, and actually from many, many bots, you can choose either. Where Composer really comes into its own from a development standpoint is, you saw me today using the built-in actions. I can actually really easily fire up Visual Studio, open the SDK bot that sits underneath my Composer project, and I can start to actually build my own custom actions to drop into that canvas to do things like connect to third-party platforms. For example, I've recently been working on a number of actions to allow you to handle things like human handoff and connect to systems like LivePerson or Dynamics, or even integrate with the Microsoft Graph by calling out for calendar information.
Yeah, well, that's a great segue into another question we have from one of our guests over at Learn TV. From Johan, he's asking, can you have different services available depending on the channel, i.e. some services are for employees only and others for customers depending on the Teams or the web as a channel?
Yep. Yes, you absolutely can, and it's really, really up to you. Every message that you receive into your bot, it's called an activity, the activity underneath, and it actually has a bunch of metadata on it that tells you what channel has this message been received from, which user has it been received from. And so you can actually then use conditions inside of Composer to offer up different types of functionality. So if I receive a message and it's on Teams, then I might want to surface up some HR related information. I know that that's going to be an employee. Whereas if it was web chat, maybe I'm going to surface up something that's more customer facing. It really depends on your scenario. Most of the time, you're going to find that actually the use cases will fall into, customer or internal, and potentially you have two bots that maybe talk to each other at times or share some code. Underneath, this is a web application, so anything you can do in terms of code sharing, etc., with a traditional web application, you can actually do with a conversational application using Bot Framework as well.
Excellent. So a question that comes to mind related to that is, let's say I do have an external service that I'd like to send. Let's say I want to collect some information from my users, and then I want to pass that on out to an external service and then maybe get some information back from it. I'm guessing, sounds like that's also possible.
Really, really simple. And in fact, if I just switch back over to Composer, I don't know if we can just pull it back up on the screen.
Pull your screen back up there.
Really, this is, here we go. So as I said, Composer has a number of different actions, right? So at the end of this dialogue, if I wanted to, I could access an external resource and I'd send a HTTP request. So when I click on that, that's going to add this action. I can specify the type of the method. I can specify the URL for the where the HTTP request should be. And then you have this thing called result property. And in here, I could say something like dialog.result, and that's going to store the results of the HTTP request in that variable in memory.
Excellent.
Now that that's there, I can then actually call out to that variable as part of my follow-up actions. It's stored in memory for me, and I can store that at the user level, so it's available across conversations, or I can store it at the dialogue level so that it's just available within this context. Beyond that, custom actions within Visual Studio or Visual Studio Code is the way to go. If you want to connect to a system and do something a little bit more complex than maybe just a HTTP request, actually have some business logic abstracted away, you can actually build your own custom actions, and once you've integrated them, which takes a few minutes, you get an extra menu option in here called custom actions, and your actions can be added to the canvas just like any of the built-in ones.
Excellent. Okay, cool. Well, I'm looking forward to playing with that for sure. Because that would really top off, put a cherry on top of some really fun projects I got going on. I could send some information, collect information from chat, send that over a place, bring it back. Awesome stuff. Let's do one more question before we transition on to our next talk. Brandon Toes over in Learn TV chat has asked, how natural is a speech-driven conversational AI? Specifically, is it pretty obvious to the customer that they're talking to a bot?
You know what? If we were having this conversation 18 months ago, I would say, it was pretty obvious. But actually, with conversational AI, you're seeing the coming together of lots of different cognitive services, like our speech service and the language understanding service that we've already seen today. Thanks to language understanding, we can now understand humans very, very easily once we've built that model. So it's not like every single time I say something, it says, sorry, I don't understand, let's try again. And gone are the days where I need to do press 1 for this, press 2 for that, right? I can just use natural language.
Yeah.
On the way back out, in terms of how the bot speaks, we now have phenomenal, natural, so natural sounding voice fonts, neural voice fonts as part of the speech service. And they can be used in front of your bot using the direct line speech channel, which is available through Azure Bot Service. You can pick one of those custom voice fonts, and the voice sounds so incredibly natural that it can feel really, really engaging to be having a conversation with the bot. And I think that's only going to improve. Even over the next few months, I expect to see further improvements in that. But it's absolutely, one of the most common scenarios I think we're going to see in the next 12, 18 months is speech-driven bots.
Yeah. It's getting very difficult to tell the difference for sure in chat. And I would say a lot of it, just watching your demo and poking around in there myself, a lot of it I think can be covered. It depends on the implementation. Depends on if you put your own trigger phrases in there and your intentions, and you marry those up and you say, if somebody says help, that could mean this, this, and this. If they say, you'd get to decide how natural, I guess, you want it to be.
Yeah, and I think a good point there actually that you make is we had a help trigger in the project today that you saw that was at the top level. So anytime I said help, it's going to show me that generic help message. You can make these things as natural as you want. You can actually have nested triggers like you saw with the edit comment trigger within dialogues. So I could have had multiple help triggers, each one of them inside a different part of my conversation. And if I say help whilst I'm filling out the vacation request form, I'm going to get in context help at that point. Using those triggers to help with disambiguation, context switching, and interruption, really they're the sorts of things that make things feel more natural. And that's why I chose to focus on interruption today, because it's how a conversation works with a human. And if we can map those paradigms, then we're onto a winner.
Yeah, when you can, if you're going to derail the conversation, which is going to happen anyway, you better have something in place that can bring you back and pick up right where you left off. So really cool stuff. Well, tell you what, Gary, let's bring in our next guest, our next speaker, and the three of us will chat for just a moment. And good job. Thank you for the presentation. And there's been some really great questions in chat. We'll continue to answer those, and we'll answer them throughout the rest of the stream. Seth, my friend, how are you?
What it is, my friend, saving the best for the beginning, and then whatever's left over for the end.
It's a Seth sandwich today. We got you at the beginning and the end.
So sorry. I don't know what prize in Hades all of y'all won that you have to have a Seth sandwich. Sounds delicious.
Good.
How you doing, Gary?
Doing well, my friend. How are you?
It's been too long. So it's
it
good
has.
to see you.
Yeah.
And Jason, how are you doing during this glorious pandemic? Happy pandemic to everyone. How is everyone celebrating?
Well, I've been celebrating in my basement most of the time on
So
live
not
streams.
different than regular life then, huh?
No, not really. Not at all. Yeah, no, it's been, we're getting by.
Here's my sound effect. There you go.
That's, I hear that in my head like all day, actually. But no, it's been going good. And honestly, today has been quite a highlight of recent memory, actually. It's been so good to see some lovely familiar faces. It's been good to work on a big project like this. We're used to traveling around and doing this type of thing. So being able to gather up and do it in a different fashion is very, very familiar and comforting. Feels good.
That is correct.
Let's go ahead and move forward. Gary, thank you so much for your presentation and
Thank you.
the Q&A. Hang out. I'm sure more questions may be coming in. Seth.
Yes, sir.
We saw you in the keynote with Vinky.
Yes.
It was awesome. Just give us a real quick, and we'll dive into it. Give us a quick highlight of what we're going to be talking about in your presentation.
So over the course of today, we've been talking about AI with generalities, and we've been talking about how to actually use models in a very productive way for business cases. For example, we looked at chatbots, we looked at search, we looked at a number of other things from the beginning. But remember that most of the time we were using AI models without really understanding how they are being built and how others can build them too in a fast way. So today we're going to talk about starting to build machine learning models faster than you think, because the process is actually not as cumbersome as it's cumbersome, but it's not intellectually cumbersome, if you know what I mean.
Yeah, no, I totally know what you mean. I'm going to give you the stage and let you go ahead and clean up for us and wrap things up. Thank you so much, Seth, and I'll let you go from here.
Let's do it. So hopefully my screen is up. I can't see it because I switched screens. So again, we're going to be talking about starting to build machine learning models faster than you think, and they've given me 15 minutes to explain the whole of machine learning. So let's do it. We're going to talk about what machine learning actually is. We're going to talk about the model building process, and we're going to build a model with no code using Azure Machine Learning Designer. And I bought a brand new thing. If you see this, this is what's called a Wacom tablet, and I'm going to try to draw on these things. So if it goes horribly wrong, we can all laugh at me together. It's going to be wonderful. So the first question is, what is machine learning? And that's a good question, because sometimes it gets conflated with this thing called AI, right? Artificial intelligence, or AI, is what you need to put in the name of your startup to get extra funding. That plus blockchain. And that's what it's turned out to become now. AI is like this marketing word, but it turns out that AI has been around for a very long time, and you've been using AI forever. If you've ever played a chess game or a tic-tac-toe, or you ever use like a map thing to help you find which way to go, that is AI. And to me, AI is, and here we go, I'm going to write something down, is something I like to call glorified search. Think about it. Basically, what it's doing is it's trying to find the right answer in an intelligent way. And if you look at like AI algorithms that are really good at that, there's things like A*, there's something like Minimax. These are algorithms which people don't think are AI, but they're actually AI. And I like to call it like the hard AI problem, because the structure is very fixed. But then we get into certain problems where it's not as fixed. For example, tell me what's in a picture. Notice that when you're solving for tic-tac-toe and AI, the states are very fixed and the search space is very finite. Even in chess, even though there's a lot of space for where you can move, the search space is still finite. But when it comes to things like finding out what is in a picture or what someone said from an audio file, the search space becomes a little bit larger, and that's when we get into algorithms such as for machine learning. Machine learning is a subset of AI. And what you do with machine learning is instead of trying to come up with a way to search the space and come up with an answer, instead you give it examples of the right thing to do and it figures out how to do it. So for example, you may have heard of things like decision trees or SVMs or things like neural networks, right? Or for spinning out the space of things like PCA and k-means. These are all algorithms that are known to be machine learning algorithms. Now, you've also heard of something called deep learning, right? And deep learning is a subset of machine learning invented by marketing people to talk about neural networks that are pretty deep. That's it. Yeah, I don't even know what to say more about that. Deep learning is basically neural networks that have really big structures with millions upon millions of parameters. So let's talk about, like, if you're a programmer, and I'm going to lower my voice here, I'm peaking. If you're a programmer, you know, or even if you've done something in Excel, you know that the way that you do things is you basically have like something that you want to put into Excel. You run some other thing on it, and then you get the answer out that you want Y, right? So for programming, this f of x for us, and I'm using these things, but don't think mathy, just think I'm writing stuff down. For us, this thing is something that we physically have to write. Like we have to have like code, like, you know, if x equals 2, then, you know, we write this out. This is something that we are in charge of. So I'm going to put that in the royal we. So when we're talking about programming, whenever we have an input that we want to convert to an output, basically the fundamental unit of our programs is this thing called a function. And functions, you know, if you're doing object-oriented, you can group them into classes. If you're doing regular functional programming, well, they're all just functions and you can put them all together into modules. But basically, regular programming is taking a function, is making a function such that it converts an input to a desired output. Now, machine learning messes that up because it turns out there are certain things that are just hard to write. So if you look at a picture of, for example, Seth, how do you make a function such that it comes out and says, oh, y equals Seth? What series of statements can you write to do that? It's nearly impossible. And so for that, we have machine learning. And what machine learning does is it separates it turns the whole thing on its head. And now instead you give it the answer and the actual thing that happened that you're going to put in. Magical stuff happens here, and out comes the algorithm. That's what machine learning is. Now, let me go back so you can see. Remember how the function that we wrote was in the box? Now we're giving it as input the answer as well as the actual input. Machine learning happens, and the algorithm comes out. So what does that process look like? So that's a good question, because if you're looking at this, notice that right here, let me get my pen, right here, this here is what we call data, right? And out here, the thing that comes out is this thing called a model. And to be precise, these things are called features, and this here thing is called the label. And what I'm describing for those of you that are machine learning practitioners is this is called the supervised learning problem for machine learning, because you're basically giving it the X and the Y, and out comes the answer. And that's what we're going to be building today. So what does the process actually look like? And that's a really good question. Well, you always have to start with data. So there's our data. And then the reality of the matter is to go from something that we have to something that we can use for machine learning. This here is the actual, like, you know how whenever you want your yard to look beautiful or you want to make your house look nice, there's like this garbage work you have to do. You know, before you paint the wall, you got to clean stuff up and you got to put the tape on, and then you got to put down tarp and stuff. This is basically the garbage work of data science, because it's called data cleaning. There's some transformation of data that happens so that then you get this data. I'll put a hat over it that's now changed, right? And now that you have this data that's been prepared specially for your machine learning models, then you can get into the process. So let's see what that looks like. So what we do is let's just take 80% of the data. So what I mean by that specifically is think of this like as a table. You're taking 80% of the rows randomly. You're doing some machine learning process so that out comes this new algorithm we'll call F hat. And you're probably wondering, well, what does this look like? Well, it's not magic. You actually have to tell it the model shape. And what does that mean? model shape? Well, you have to pick a machine learning algorithm that you feed the data through, and those things are called basically I call them model shapes. So, for example, you could use a decision tree, you could use an SVM, you could use neural networks, etc. And what happens is then the parameters of that machine learning model are produced in such a way that you get this algorithm. So how do we know if this thing is even the right thing? Well, that's a good question. Then we go over here, and there's a reason why I said 80, but it could be 70 or 50 or whatever. But whatever is remaining of the data that comes out, we split it up, and what we do is we test to see if this machine learning model that it produced is good, and if it's good, we put it out into production. Does that make sense? So that's literally what's going on. So if this thing doesn't go right, for example, let's go to pen and choose black here. So if this is like wrong thing, then what we have to do is we have to go to this step again and maybe use a different model shape. If this model shape doesn't work, or for example, there's parameters in the model shape that we can change, we do this over and over until it works. And if this doesn't work, then we have to go all the way back over here and take a look at the data and see if we have to clean it up again. So that's why you're probably wondering, well, then why is it called data science if it feels kind of squishy? Well, it turns out, friends, that science is a glorified way to guess and check. If you think of the data science, if you think of the science process, you start with a hypothesis, you test it out, and you go throughout. And this is the process. Now, I want you to remember this picture, because the cool thing about this picture is that you're going to see something similar to this, right? Because when we're going to build models, remember this particular picture of where we have data, we have some transformations, then things get split out. We have to tell it what model shape to use, and then out comes this thing. Then we got to test it, and then we can put it out to production. So remember that. Now I got to make sure I hurry up because I don't want to run out of time. So in our case, we're going to do Tailwind Traders. And with Tailwind Traders, we have a store 1, for example, and store 2. And we want to make sure that store 1 and store 2 are stocked well. This is a time series analysis thing. So we want a machine learning model that will say, okay, over the next 4 weeks, how many of product foo should I have at store Baz? Is basically what we want to build. And we are going to start to do that right now. All right, so here we are. This is what's called the Azure Machine Learning Studio. So let me go ahead and bring the chat up. If you have any questions, make sure you get them in. I'm monitoring literally right below me, so you can totally look at it. So I don't need this pen anymore. That was glorious. The first time I've ever used a tablet like that. Winning. All right, so this is Azure Machine Learning Studio. And remember, the first thing we have to start with is the data. But I've actually cheated because remember that there was actually 2 data steps. Remember the 2 data steps? The first one was garbage data and then cleaning data, right? So right in this area. So I've already actually cleaned it. So I've already done that step. And the reality of the matter is that we need the store, we need the product number, we need the time of day, and then we need the number of things of that product that were sold at that store. So here it is. This is the data. So let's go ahead and let's just view it here. So let's go to Explore. I'm having trouble hearing you. Oh, sorry. My AI on my phone is having a hard time hearing me. So when you're looking at this, just think of this as the store ID, think of this as the product ID, and think of this as the time. Now, this value is actually been scaled because we had to clean it a little bit. And so log scaling allows you to look at the spread a little bit better. So that's what this is. We've actually added some features as well. This RDPI stands for the, I wrote it down on a card and now I don't have the card. Hold on. It stands for like the real, like how much money someone has, real disposable income or something like that. And so this is how much the real, and so we added that as a feature. And then we separated the features out by like year, month, week, whatever. We've added some more things like, is it Labor Day, whatever. And now these other features, you're like, what is that? This is called a fast Fourier transform to get the signal into its various signals. And this is something that people do, and it may work or may not work. And you're like, what is this lag? It turns out that we can also add like from the time n-1 all the way to the time n-20 26, right? And so at the first there's 0, and then the values for what it was before, because now what we're doing is we're creating this augmented thing to train our data set. So how do we know if it's good? Well, we separate the data out, 80-20 or 70-30, and then we test the model. So let's go to the designer and let's actually build it right now. So I am going to just hit plus here, and let me bring this up. And what I'm going to do is I already have this data set in there. So Tailwind Traders forecasting. Oh, I do need to tell it like what computer we're going to use. We're going to use Gandalf because I'm a nerd and I like Lord of the Rings. So remember, this is where we start with the data, but it's already clean. So you can imagine a scenario where we would have more things to clean it, because again, that diagram that I did from left to right, now we're going to do from top to bottom directly in this designer. All right, so now what we need to do is we need to select the columns that we want, columns. So I'll pull that here and then literally just boop. And for this, what we want to do is we want to take all of the columns except for the ones that we don't want. So let's just take all of the columns, boom. And then we want to exclude all the ones that we don't want, and that would be the time, because remember we separated that out into its constituent parts, and this really is not, it's monotonically increasing, it won't help us. Booyah. The next thing we want to do, just like I said, is we want to split the data. So I'll go to split. By the way, as you're seeing me do this, you're probably wondering, well, what kind of things can you do? Well, it turns out that there's a ton of amazing things that you can do, from data sets to input and output to transformations to selecting features. For example, if you want to use a filter-based feature selection, this will actually choose the features for you. Remember the X that's coming in, we'll choose them for you by doing some amazing tests. Like, for example, there's a chi-square test that tests every feature with the output to see if they're related somehow, and then it chooses the 5 ones that are most predicted. All right, so here we're going to say, let's take 70% of the data. Wonderful. And then the next thing we need to do is we need to train the model, right? Train model. There you go. And so we're going to take the data here and train the model like so. Remember, because we split the data out, and this 30% is going to go out here so we can test it. Remember, what was the input that we had to have for a trained model? Well, we had to pick a model shape. In our case, we're going to use boosted decision tree regression. And the reason why we're using regression is a way of getting a real value. Classification is a way of getting a like a one or the other value. So discrete value, for example. So now that we have the trained model, we just need to tell it which column we want to learn. And in our case, the column name we want to learn will be value, which is how many of the products we want. By the way, these have been converted to log space, as you know. And then the last thing we want to do, well, last 2 things, is we want to score the model, boom, to make sure how well we're doing. And what do we compare it against? Well, with the other 30%, boom. And then the last thing we want to do is we want to evaluate how well we've done, boom. So then we do that like that. And you're probably wondering, why is there another input? Well, because you can actually do multiple models and compare them against each other. How's that for cool? All right, I think we're done, so let's run it. Let's make a new experiment. Now, this thing is going to take some time. I got to say new experiment, new time series. And then I have to put an underscore here to make sure it works. And then I hit submit. Now, this thing is going to take about probably 15 minutes. So what we're going to do is we're just going to sit here and stare awkwardly at each other. I'm just kidding. I'm not going to do that, because why would I? I actually already ran it myself because I'm a good presenter. And what you can see is that as you're going through, you can actually look at everything that is happening in each of the steps. Like, for example, let's take a look at the data set with the right column removed. There it is. There you go. It's pretty cool. What about, sorry. Okay. What about when we train the model and score the model? What is actually coming out? You can actually look at all of the logs of everything it actually did as well, because this is actually computer stuff that is happening. And I've had some data scientists tell me that they're concerned about this because it feels black boxy. It's not. Like, we're running things so you can see exactly what is happening. And then when we evaluate the model, we can actually look at, for example, let me move this over here. we can actually visualize the results of the actual output, and we can see what the mean absolute error, root mean squared error, and the lower these things are, the better. But now you're wondering, well, I want to put this into production. Let's just say that all of those parameters have been great. We want to put those into production. What you can do is you can actually, let me go over here, create a real-time inference pipeline, which is really cool. And the way you do that is you basically go over here to the training pipeline and you can create a real-time already made one, so just update, or a batch inference pipeline, already made it. So let's go over to the real-time inference pipeline and notice that now, since the model has been created, now the input to the score model is a model that's been saved, right? And it's been saved automatically inside of Azure Machine Learning. You can see there is the models, right? And you can save the list of models. I have a bunch of models that I built myself as well, but it saves the models. And let's go back here to the real-time inference endpoint, and you can then deploy it by clicking this button. And that's it. It creates an endpoint for you. Here is the endpoint that it created for me. But the reality is, like, now I got to write some code. All right. Let's write some code. Sorry. I'm just kidding. It turns out that we wrote it for you. So let's just cut and paste. Boom. And now I can just write this out like this and then hit F5. And guess what? Now I can literally call this model that has the predict. Well, let's just change a little bit of code here. So we're going to change the result so it does JSON stuff, because in honor of Jason Hand here, who's here. So we'll run it again, and now we're going to start to see that as we put stuff in, here's the answer that is coming out. Here's the data that we're putting into the model, which is the same things we had before. And now we can start to actually get the real answers. So let's get the store ID out of the response. Let's get the product ID out of the actual response. Let's get the value that we got out of there. We're going to need to do some math, if that's okay. So we're going to import math. And then I'm going to print out. Look how good. I'm so good at typing. Thank you. Yes, so good at typing. I'm changing this code in such a way that now when I run it, it's going to tell me, hey, guess what, Seth? Stock store 1 with 241 products of ID 2 for the next 4 weeks. And you're probably wondering, well, does that change with the store? Well, let's try it out. F5. Stock store 2 with 254 products of ID 2. What about of ID 1 for store 2? Let's run that again. Hit F5 here. Oh, you only need 145 of those ones. And that's it. Basically, we've gone end to end inside of this amazing designer to create a forecasting algorithm that's actually useful. Now, I want to make sure to finish out with some of the slides here so you can get a sense for where you can go to learn more. But this is the bulk of everything I wanted to show you, because they said I only had 15 minutes and I might have been over a little bit. So, Jason, my friend, what do we got?
We have lots of stuff.
Cool.
That was amazing. Thank you, Seth. We do have just a little bit of time left, so we'll get in some questions here. But yeah, thank you for so much of that. I've got a bunch of notes here myself, but
sure.
You mentioned you've got 15 minutes to explain artificial intelligence, machine learning, all that kind of stuff. You did a great job of putting that in there at the beginning. But what I've noticed throughout your talk, and really all of them, is that it seems that so much of this now is obviously very approachable because we've found better ways of explaining how this stuff works, but also through the tooling that we have, whether it's the no-code route or you've got this nice interface like you showed, where it's a visual deal where we can drag and drop. That, I think, breaks down so many barriers into this whole world of machine learning. I mean, you definitely showed some things that can be scary to people. We jumped into some code. Somehow you typed a bunch of stuff super fast. There's things that people don't quite understand. It feels like magic, but we're getting rid of, or I shouldn't say we're getting rid of, we're creating scenarios where that magic is now in your hands. You can do that stuff, and it doesn't matter that you don't know what's going on behind the scenes.
Yeah, I mean, just like anything, whenever I wrote my first line of code in general, I did not know what was happening in the device. I didn't know it was getting translated into like assembly language and then running on a circuit and then loading up into the, look aside buffer inside of the CPU. I didn't know any of that was happening. And obviously I didn't need to.
Yeah.
I knew that my code worked, and that's what mattered. And so now we're getting to a place where I think machine learning is similar, just like you said.
Yeah, exactly. It's very similar to, I don't know, just so much of the stuff that we're learning within Azure is making it, I just keep coming back to the word approachable. One of our guests had a comment earlier about how Microsoft has made so much of this stuff just easier to get into, to jump into. We got the Learn modules that we've been, pointing people to so that you can go immediately soak up a lot more of this information, because we're giving you a fire hose of stuff. 15 minutes isn't a lot of time to really cover much. Send you over to the Learn modules, and you can take your time learning stuff there. There's exercises that you can walk through. We'll spin up sandboxes for you in Azure, so it doesn't cost anything. Here in a minute, though, I want to bring in Amy Boyd to chat with us while we start to wrap up. I thought for sure, Seth, when you jumped in and you showed off your tablet, that you were going to demonstrate how we could make sense of your handwriting. But it turns out your handwriting is actually pretty good.
Thank you. Yeah, I practiced all night. I haven't slept in several months writing on this glorious Wacom. Wasn't that cool, though? I felt like a teacher.
Yeah, well, we were all wondering throughout this presentation, at least twice, maybe 3 times, I think we asked ourselves, how is he doing this? So very, very impressive stuff. It was fun to watch. And Amy, do you have any thoughts on not only just Seth's presentation, but also the day as well? We're starting to wrap up here.
Sure. Interesting that you said, some of us were putting, how is he doing this? That was my comment in our little backstage bit there. Seth, how were you doing the like rapid typing? I'm so confused.
Oh, the rapid.
Yeah, okay. I was like, I thought you were actually typing it at the start, and then I was like,
I know. That's what a lot of people think. I actually typed it with my mind powers. No, so I have something called AutoHotkey, and what I did is I wrote an AutoHotkey script that reads lines in a text file, and I press Control-Shift and the number of the line in the text file to write it. Because, I mean, I could write it out. The code I wrote was super simple. It wasn't anything, but it's just boring for me to be like, ooh, backspace, backspace. And so whenever I have to type any code out in a presentation, I don't want to waste people's time. And so basically I make it look like I'm typing it really fast, and then the code is always right. And so that it's called AutoHotkey, and I wrote a special AutoHotkey script that reads every single line in a text file, and then I press Control-Shift and the number of the line, and it just literally writes it out like I'm typing.
Nice. You completely beat my Shift-Alt-F to format JSON. That blew my mind. So you beat me. Done.
That's a good one. But by the way, I want people to understand that like some of the stuff that I did is kind of complex. Like this particular problem, because this is the one that I was assigned to do, can be a little bit harder because the data preparation requires some mathiness to it, but it really isn't. We're just adding features to the thing to make it predict a little bit better. And so I used really big words like log space and fast Fourier transform. Don't worry about those things. I only say them so that they promote me at Microsoft.
Well, it's funny you talk about the fast Fourier transform. That's actually one of the questions that we have in chat from Shane. Can you elaborate a little bit more on what that exactly is?
Absolutely. So whenever you look at a complex function that has a periodicity to it, so for example, a sine wave, or you're looking at audio files. No, ever seen the audio wave? It's like a big squiggly bunch of waves. What the fast Fourier transform does is it separates it into its constituent frequencies. So for example, if you think of any complex waveform as the sum of sine or cosine waves, you can add them together by moving them around. And so what the Fourier transformation does is it separates out the frequencies. And so what we've done in this particular case is we're assuming that the periodicity of products at a particular location has a frequency that it follows over a certain period of time. And so we're faking frequencies of that things by pulling the constituent base frequencies out of them and then adding them back in as features. It's a way of getting more features out of a single feature, because we know there's a periodicity to it, or we assume there's a periodicity to it, and that fast Fourier transform will be able to pull out the frequencies. So that's what we're doing. I think we pulled like 6 different of the constituent waves or frequencies that are in there. And that's an interesting math way of looking at it. So math actually really helps with these things, but you don't need to use it, right? It may have been that in this case, the model worked fine with just certain kinds of features, but we added more to make it more powerful.
I think a key thing to talk about there as well is because that sounds quite complex, and we don't want to scare anyone off in some of those elements. Obviously, a lot of what we've seen is very developer heavy, and then this session that Seth provided for us was that first step into, okay, like if I want to take everything a little bit further, if I want to know what's going on behind it and build something more bespoke, this is a really nice first step in some sense. The tool is a really neat tool to actually not have to worry about all of the code underneath and actually focus on the theory of what you're doing. And then also, I always get this, and Seth, I'm sure you do the same, but you just like know a load of stuff as well. But Fourier features and lag and stuff like that is really specific for forecasting problems.
Right.
If you're not into forecasting, say you're doing computer vision or text processing, it might not be like the same thing. So it's always when someone says, oh, like someone is like an ML expert, and then someone will come and talk to you about a certain problem, you're a little bit like, like I actually haven't done stuff in that space, and that's totally cool. It's like all of the technology, right? You specialize a little bit, or you build from experience.
Yeah, and I'll add that like it wasn't like I had to look this stuff up last night, right? Because I'm like, what are they doing here? Let me see. Because I am a very good speaker, and I prepare the night before for things like this, obviously. And so, like, for example, just think of a lag feature, and just think of it like intellectually. If you want a feature that says this is how many products you need, why not have as other features how many products they needed, like time n-1, n-2, n-3, because those can inform the model a little bit more. And so most of these things can be common sense once you think about it, but then getting to the common sense requires someone to tell. Like I had to go look some of this up. Like, for example, the value they put into log space, and you're like, well, what the heck does that mean? It means that it scales the number down in such a way so that it's not overwhelming the algorithms. And you're like, well, why would you do that? I had to go look it up because it makes it so that it's a little bit less spread out over the higher ends, right? And so there's some really clever math techniques, but they are not necessary to get started. They're necessary for time series. But for example, if you want to look at my screen here, let me show you here something real quick, because I know people are like, wow, this is kind of scary. So can we go to my screen? Look at this regression. I just click on this and it basically builds one for you. There's no craziness. If you look at the data, it's basically like automobile data. And so it's this you're looking at, you're like, oh, I get this. And you can go through and run it. Like, and I noticed I didn't prepare this demo. I just clicked like 2 buttons, and now you can go and see how this particular thing works, which is pretty cool, I think.
Yeah, I mentioned that actually to someone else in the chat as well. I was like, oh, go and take a look at other forecasting ones and other examples. And so, yeah, whoever I spoke to in the chat, sorry, I've not got it up. That is the great place to go. There's all those samples. So if you're trying a new problem, they're always a good first point of call.
And I will add that I am not a forecasting expert. My colleague, Francesca Lazzari, she is our forecasting expert. I just, there's like, here's a sample, use this. I'm like, okay, let me go learn as much as I can. And so that was a product of me learning stuff yesterday. So
always be learning, Seth. That's what we're here for.
That's right.
Hey, so one of the things that you mentioned, I think very early on in the presentation, was auto ML.
Yes.
I believe you just kind of glazed over that a little bit. Can you give us a little bit more about what auto ML is? We try to address one of our questions from the chat.
Absolutely. So let me go back to this slide here. If you want to go to this slide here, and if you are, that's great. If you're not, that's okay. You remember there was this part where we didn't know if it worked, so we had to do like a for loop to change the model shape and the model parameters, another for loop to change like data. So imagine this scenario where you have a model shape and model parameters and a for loop to loop through like different models and different model parameters. What AutoML does is it just does this for you. It selects a bunch of models, it tries them all, it tries different parameters, and it says, here's the best one that we found. So that's what automated machine learning does inside of Azure Machine Learning Studio, is it basically gets your data, you say, this is the thing I want to learn, and then it loops through models and loops through parameterizations of the model. And so that's what automated machine learning does, right? It basically just takes the work out of it. Now, data scientists have told me, well, how that takes away the work that I do. And the reality is it doesn't. It basically takes away the garbage work that we do, which is basically figuring out which model will work best with which parameterization. And what we've done is we've saved data scientists like 2 or 3 weeks worth of work and condensed it into a weekend's worth of computer time on our cloud, which is amazing. So then when you actually start working on the problem as a data scientist, you'd be like, oh, it looks like tree-based models seem to be working a little bit better. Let me try that. Or neural network-based models are working a little bit better. So let's go down that line of inquiry. Because remember, this is all science. We don't know what's going to work until we try it out. But let's let automated machine learning try a bunch of things for you over the weekend. And you can look like a genius on Monday morning when you got something that works.
Yeah, and it's not just all that stuff, all the different models or whatever that's running through. The other part that gets handled over there too is the compute, and you decide how large of a compute cluster you're going to use or whatever. And one I would say thing to keep in mind is once those, especially if you choose large compute clusters to run your models on and do all these different computations, you'll want to spin those down when you're not using them, or put something in that spins those down.
Little secret. Don't let anyone know because they pay us to use our computers. Basically, we can set the min node count on our clusters to 0, and they will shut off on their own after 5 minutes of inactivity, saving your wallet and making it so that I cannot go to Disneyland whenever it opens again.
Yeah, best trick. I think Amy taught me that too. Saved me big time because I had some large clusters running some compute last year. For demos, and I think she asked me something about it, and I was like, oh my gosh, it's been running for like 2 days. So yeah, I forgot to set it to 0, but that is a nice little feature.
That's right.
A couple other questions too in here before we start to wrap up, and I know we want to talk about some of the Learn modules right before we go, Amy. Another question from Brandon in Learn TV chat is the result from AutoML typically better than what a person would do?
It depends on how skilled the person is. If it's me, the answer is yes. It would be better. Because the way I do it is if I was given a machine learning problem, I always start with like white box based models. And what that means is that you can actually look at what's happening inside of the model, like decision trees and maybe some logistic regression type stuff. I would always start with those. And then I would up the model complexity as I go. Right. And so the reality is that it will come up with something faster. Will it come up with something better than a human? I don't know. I forgot to add that the thing about automated machine learning, which makes it interesting, is how you're watching Netflix and it secretly judges you, like, hey, are you still watching?
Yeah.
When you finish a show, it also says you should also watch this, right? It turns out that automated machine learning actually uses a machine learning recommender system under the hood so that when it finishes a particular run of a model, it looks at the output and says, oh, if you like this model, you're really going to like this one. So we're using machine learning to make your machine learning better. It's like Inception, but for machine learning. And that's really the coolest part, I think.
Yeah, no, you're totally right. I love it. Hey, I just looked at the clock and we are almost out of time, friends. So Amy, do you want to go through these real quick? Let's just talk about where all have we sent people today, and what for, and what's next.
Sure, yeah. So we have had 5 amazing talks, as well as so much Q&A. So thank you so much for getting involved in asking really, really good questions to our speakers. But every single session that we've designed directly relates to a Microsoft Learn module that is based also then on our AI Fundamentals certification. So everything you've seen today, I hope you take it away as inspiration. Do note down all of these links. So everything is ak.ms/AIML, and then do 10, 20, 30, 40, 50 for each session that we've seen today. So if you're looking for conversational AI, go to AIML 40. If computer vision was an interesting piece for you, go to AIML 10. Or if designer, what Seth just showed us, is of interest, go to AIML 50. But as I said, if you did all of these different modules, go and try and take that AI Fundamentals certification, because these will set you up in the right path for that.
Excellent. Awesome advice. Great tools, all free for everybody to use. So please go check those out. And we are out of time here. So thank you so much, friends. Amy, thank you for putting this on. Seth, for joining us and speaking. Everybody else that's joined us all day long. Thank you to our moderators in chat. Thank you to our producers, Juliet, behind the scenes, keeping things flowing and keeping us on time. Thank you mostly for joining us on the very first All Around Azure, a developer's guide to AI. We hope you've enjoyed the show and you've learned lots of things. And we look forward to talking to you again. We'll see you next time.
Take
Bye.
care.